When a forest dies slowly, nature usually leaves a trail. Roots weaken, soil changes. Insects arrive, fire moves in waves. But in one remote morning, a living landscape was pressed flat almost at once, while the thing that did it left no ordinary crater behind. For human history, the colder thought is not that the sky can strike the earth, but that most of our past happened beneath a sky we could not understand. So what could flatten tens of millions of trees in seconds, and still leave us asking? Something flattened 80 million trees in seconds, and nobody knows what it was. Before anyone knew the name Tunguska as a mystery, there was only forest. The land was not empty, but it was quiet in a way that most cities can no longer imagine. Dark spruce, larch, and pine stood across the Siberian taiga, rooted in cold soil that thawed only shallowly in the warm months. Rivers bent through marsh and stone. Reindeer paths crossed human paths. Smoke from small camps rose and vanished into a sky so wide that it could make even a dangerous thing seem distant. On that morning in 1908, the trees were not ruins, not evidence, not a puzzle for later science. They were living bodies, each one holding water, resin, rings of weather, and the slow memory of seasons. Then, in a span too brief for a forest to understand, the order of that place changed. Something came from above, or seemed to come from above, with light, pressure, heat, and sound. The ground trembled. Air became force. Across a vast reach of woodland, trunks were pushed down as if an invisible hand had passed over the earth and pressed the living surface flat. For people who heard it from far away, it could only be described through the language of the body. A flash seen in the sky, a wave of heat, a shock that rattled walls, a noise that arrived like the world breaking open. Yet the most important fact is also the quietest one. The event happened in a place where human record was thin. There were witnesses, but not a city full of instruments. There were stories, but not immediate maps. There was damage, but the first deep scientific reading of the landscape would come much later, after weather, decay, fear, distance, and time had already begun to erase the first shape of the wound. That delay matters. In human history, many events have been lost not because they were small, but because they happened beyond the reach of writing. Roads, governments, or laboratories. For most of our existence, our ancestors lived under skies they could watch but not measure. A bright streak, a sudden cold, a strange sound, a fire in the distance, these were not data points. They were experiences carried in memory, repeated beside fires, altered by fear, and folded into the meaning of a landscape. Tunguska sits at the edge of that older human condition. It occurred in the modern age, yet in a corner of the world where modern observation arrived too late to catch the event itself. That is why the fallen forest became so important. It was the witness that remained when the sky had gone silent. The trees did not explain what had happened, but they preserved direction. Some lay outward, pointing away from a central region. Some nearer the middle were reported standing while stripped and burned, as if the force had descended from above rather than swept along the ground like a storm. There was no ordinary crater waiting there, no simple hole that could make the story easy. Instead, there was a pattern, and patterns are slower than answers. They ask to be read with care. The first human response to such a scene is often to search for a single object, a stone, a metal fragment, a pit, a mark that says, "Here is the thing." But Tunguska resisted that comfort. It gave the world a flattened forest and withheld the familiar sign of impact. This is where the mystery begins, not with fantasy, but with restraint. A powerful event clearly occurred. The damage was real. The witnesses were real. The missing crater was real. Yet reality did not arrange itself into a clean sentence. For a sleep listener, there is something strangely humbling in that. A forest can fall in seconds, but understanding may take generations. The Earth can keep an event on its surface and still refuse to make it simple. Long before science had satellites, global sensors, or networks watching the sky, human beings learned the world from traces. A footprint in mud, ash in a cave, a broken bone, a ring inside a tree. Tunguska belongs to that same ancient habit of reading what remains. It begins with a morning when the sky acted faster than human thought, and a forest became the first page of a question that has never fully closed. The morning did not announce itself as a turning point in history. It began as an ordinary summer morning in central Siberia, where light came early and the land held both warmth and cold at the same time. Beneath the trees, the soil still remembered winter. Above them, the sky opened over a region so distant from the main centers of power that news could weaken before it reached anyone with a map. People living near the Podkamennaya Tunguska River did not stand outside history, but they lived in a world where history moved differently. A sound could cross the forest faster than a message could cross the empire. A flash could be seen by the eyes but not captured by a camera. A shot could pass through a body, through a tent, through the ground itself, and still leave later generations asking how to name what had happened. For the people closest to the event, the first truth was not scientific. It was physical. The world became too bright. The air grew violent. The ground behaved as if it had received a blow from something immense. Some witnesses later described heat, noise, trembling, and a force strong enough to throw people or shake buildings. These are not the words of instruments. They are the words of bodies trying to remember a moment when the sky became dangerous. That matters because human beings have always known the world first through the body. Long before laboratories, long before written records, long before any person could calculate an object entering the atmosphere, our ancestors survived by reading sudden changes in light, pressure, animal movement, weather, and sound. Tunguska belongs to that older way of knowing, even though it happened in the 20th century. It was modern enough to be investigated by science, but remote enough to be experienced first as awe, fear, confusion, and silence. The forest then became the place where the event wrote itself down. Trees are slow witnesses. They do not speak, but they keep direction in their fall, heat in their scars, and stress in their broken grain. After the blast, the landscape did not look like a normal burned woodland. Fire can kill trees while leaving them standing. Wind can throw trees in a common direction. Flood or disease can spread unevenly, following low ground, roots, insects, or seasons. The Tunguska forest suggested something sharper and stranger. Force from a central region, spreading outward through the air. That does not answer every question, but it narrows the field. It shows why the event could not be treated as only a forest fire, only a storm, or only a local accident. The damage had a geometry. It had a center and a reach. It had a pattern large enough to outlive the people who first saw it. Yet the same forest that preserved the pattern also deepened the difficulty. If a heavy object had struck the ground in the usual way, people might expect a crater, broken stone, melted material, and a simpler trail. Tunguska did not give such an easy gift. The land held fallen trees, scorched trunks, disturbed ground, and stories from far away, but not the single obvious wound that would have ended the question. This is why the phrase "nobody knows" should be handled carefully. It does not mean nothing is known. It means the strongest explanation still has edges where evidence thins. It means the landscape gives clues without giving complete possession of the truth. Many human histories begin in the same kind of half-light. A tool found in soil tells us that hands once shaped stone, but not every thought behind the hand. A burned hearth tells us that fire was used, but not every word spoken around it. A footprint tells us that a body crossed wet ground, but not the whole life that carried it there. Tunguska is not human prehistory, yet it reminds us how often knowledge begins from traces after the living moment has vanished. The morning itself passed quickly. The pressure wave moved on. The light faded. The sound rolled away into distances where it became rumour, report, or memory. But the forest remained, flattened across a huge reach of taiga, waiting for people to come and misread it, read it again, argue over it, measure it, and return to it with better questions. In that quiet waiting, the event became more than a disaster in a remote place. It became a lesson in how the earth preserves sudden violence, and how slowly the human mind learns to approach it without forcing it into a story too soon. By the time the fallen trees could be studied carefully, the first morning was already gone beyond reach. Light leaves no fossil, sound leaves no bone. Heat can mark bark, skin, and memory. but it does not remain in the air for years, waiting to be collected. What remained in Tunguska was the slower evidence. Trunks lying across the taiga, burned surfaces, disturbed ground, frightened accounts, and a silence where a crater might have been expected. The difficulty was not that nothing had happened. The difficulty was that too much had happened too quickly, and the clearest part of the event had taken place in the sky, where traces are fragile. A forest is excellent at recording years. Each ring remembers a season of growth. Each scar may preserve fire, insect attack, frost, or injury. But a forest is not designed to explain a sudden explosion from above. It can show where force travelled. It can show where bodies of wood broke. It can show that pressure moved across the land with extraordinary power. It cannot by itself name the object that created the pressure. That is why the earliest shape of the mystery is so important. Before anyone argues about asteroids, comets, airbursts, or fragments too small to survive, the first truth is simpler and colder. The Earth was struck by energy, but not in the familiar way people expect from a stone hitting the ground. The trees became the evidence because the object itself did not remain in an obvious form. For human beings, this is an old problem. We are a species that wants causes to stay visible. A broken branch suggests a passing animal. A footprint suggests a foot. A cut bone suggests a tool. Much of human knowledge began with that habit of linking a trace to an action. It helped our ancestors survive because the world often leaves readable signs. But some events are larger, faster, or stranger than ordinary tracking. Their causes do not sit beside their effects. They vanish into weather, distance, decay, or the upper air. Tunguska forced modern science to behave like an ancient tracker standing before a damaged landscape and asking what kind of movement could have made such a mark. The answer could not be taken from one clue alone. A crater would have been a simple clue, but the land did not provide it. A large surviving fragment would have been another, but none was found in the clear way people imagined. Witnesses helped, but witnesses were separated by distance, fear, language, and time. The forest helped, but the forest gave a pattern rather than a name. This is why the event has remained powerful in the human imagination without needing exaggeration. Its real facts are enough. A remote region, a sudden flash, a violent pressure wave, trees flattened across a vast area. No ordinary crater. Scientific investigation arriving after delay. These facts do not need to be made louder. They need to be held carefully, because each one narrows the story while refusing to finish it. The place itself also shaped the mystery. In a dense capital, the event might have been measured by many clocks, photographed from different angles, written into newspapers within hours, and compared across official reports. In the taiga, the first archive was living wood and human memory. That difference changes everything. It reminds us that history is not only made by what happens, but by where it happens, who can record it, and how quickly evidence can be reached. A powerful event in an observed place becomes a documented disaster. A powerful event in a remote forest becomes a question that slowly gathers witnesses after the fact. This connects Tunguska to the deeper story of human origins in a quiet but direct way. For most of our time on Earth, human groups lived without instruments, without global communication, and without the ability to distinguish every danger in the sky from weather, fire, or divine meaning. They survived not by having complete explanations, but by noticing patterns well enough to endure. The Tunguska forest, fallen and silent, stands at the meeting point between those two worlds, the old world of traces and the modern world of measurement. It asks us to begin not with certainty, but with attention. Something had crossed from sky into history. Something had turned air into a hammer. Something had left a wound without the simple signature people expected. And in that first stage of the story, the most honest answer is not yet a conclusion, but a careful pause before the question grows larger. To understand why the Tunguska event remains so difficult to hold in a clean historical frame, it helps to begin not with the blast, but with the place. Central Siberia was not a blank space, and it was never empty in the human sense. People lived there, hunted there, herded reindeer there, knew rivers, seasons, bogs, ridges, and safe routes in ways no distant map could fully contain. But to the institutions that usually preserve modern history, it was far from the centre. It was far from newspapers that could send reporters at once. Far from laboratories that could collect dust before rain and wind disturbed it. Far from observatories that might have measured the sky from different angles. Far from the dense human network that turns an event into documents before memory has time to shift. This distance did not make the event less real. It made the event harder to translate. A sudden violence passed over a living landscape, but the world that could have measured it was not standing directly beneath it with instruments ready. Tunguska feels older than its date. It happened in 1908, in an age of railways, telegraphs, scientific societies, empires and newspapers, yet the first layer of knowledge still depended on bodies, fear, memory, and the land itself. For most of human existence, that was normal. Our ancestors did not live inside an archive. They lived inside weather, hunger, sound, animal movement, and changing light. When something immense crossed the sky, the first record was not a chart. It was a startled face, a changed horizon, a story carried to the next camp. Tunguska, though modern, briefly returned humanity to that older condition. The people closest to it could feel that something had happened, but feeling is not the same as explanation. A person may remember heat on the skin, a flash in the sky, a shock in the chest, or a sound that seemed to come after light. Yet the mind must arrange those fragments later, and later is never the same as the moment itself. The remoteness of the region also shaped what the outside world cared to know. A disaster in a capital becomes a national wound almost immediately. Broken glass, injured bodies, damaged buildings, and official reports force attention. A disaster in a forest can remain suspended, known locally, repeated in reports, but not fully entered into investigation. The tiger does not shout in the language of governments. Trees fall without filing testimony. Rivers continue moving. Moss grows over damage. Snow returns. In such a place, time begins repairing the surface before science has even arrived. The same process that allows life to recover also makes evidence harder to read. A fallen trunk dries, rots, burns again, or sinks into wet ground. A scar in bark changes as the tree dies. Animal paths cross the damaged land. The original shape becomes less sharp with each season. This matters because the event itself was not only a physical event, it became a historical event through a delay. What happened in seconds had to be reconstructed across years. The scale of the damage belonged to nature, but the scale of certainty belonged to human access. That gap is where much of the mystery lives. Tunguska also reminds us that human history has always been unevenly recorded. Some places have monuments, clay tablets, court records, ship logs, and stone walls. Other places have oral memory, burned ground, pollen, bones, tools, and trees. In the deep past, nearly all of our species lived closer to the second kind of record. Lives passed without written dates. Deaths occurred without names carved in stone. Migrations crossed landscapes that kept only faint marks. Tunguska gives us a rare bridge between that ancient uncertainty and modern science. We know it happened. We know the forest was changed, but the place where it happened controlled the first evidence as much as the event did. It was Siberia, wide and difficult, not a city square. It was forest, not pavement. It was living ground, not a laboratory floor. And because of that, the question did not travel to us as a complete answer. It travelled like a sound through trees, keeping enough force to be heard, and leaving behind a silence that still asks to be approached slowly. Distance is not only measured in miles. Sometimes it is measured in how slowly news can move, how few eyes can compare the same event, and how much of a landscape can change before anyone trained to read it arrives. Around Tunguska, distance was a condition of knowledge. The taiga stretched wider than any single witness. Rivers curved through country that could slow travel for weeks. Summer opened the ground just enough to make it wet, difficult, and alive with insects, while winter locked the land under cold that could turn movement itself into a test. A person could know that country intimately and still be far from the institutions that gave events official form. This is one reason the story must be approached with patience. The people of the region were not passive shadows in an empty wilderness. They had names, routes, animals, tasks, fears, and memory. Some were indigenous Evenki families whose lives were tied to reindeer, forest movement, hunting, and seasonal knowledge. Others lived farther out in settlements connected to the Russian Empire by fragile lines of communication. But their nearness to the event did not automatically become nearness to scientific explanation. Human nearness and institutional nearness are different things. A person can stand close enough to feel heat on the skin, yet still be far from the tools that later generations expect. Cameras, pressure sensors, seismographs placed in the right location, aircraft surveys, immediate sampling, and teams able to enter the damage zone within days. Tunguska exposed that difference. It shows how history often depends not on whether something happened, but on whether a system existed nearby to capture it before time began to soften its edges. This is true far beyond Siberia. In the long story of our species, countless storms, fires, eruptions, floods, animal migrations, droughts, and strange lights in the sky must have shaped human lives without leaving written testimony. A band of early humans could lose a valley to fire and carry the memory for a generation, but the earth would keep only charcoal, pollen, and disturbed soil. A sudden winter could change food, movement, births, deaths, and decisions, yet leave no sentence explaining what it meant to those who endured it. Tunguska is valuable because it happened late enough for science to return to it, but far enough from immediate measurement to remind us of those older limits. The region itself became a filter. What reached the outside world first were reports, rumours, fragments, and later expeditions, not a complete record made at the moment of impact. Even the word impact must be used carefully here, because the most visible damage did not come with the familiar simplicity of a body striking the ground and staying there. The damage was spread through air, forest, and distance. That made the scene harder to gather into one image. A crater can be photographed as a centre. A fallen forest must be walked, mapped, compared, and interpreted. The work is slower because the evidence is distributed. Each tree is only one mark. Many trees together become a pattern. The human mind wants the whole pattern at once, but the tiger gives it slowly, through mud, mosquitoes, rivers, broken trunks, and the uncertainty of memory. This slow gathering of knowledge is part of the real story. It prevents the event from becoming a simple spectacle. It asks us to imagine a world where nature acts quickly while human understanding travels on foot. In that contrast, Tunguska becomes more than an explosion over Siberia. It becomes a lesson in the uneven geography of truth. Some truths arrive surrounded by instruments and witnesses. Others arrive through scarred wood, scattered stories, and a damaged silence. The forest did not hide the event, but it did not translate it for us. It held the marks in its own language, and human beings had to learn how to read them. If the same burst of force had crossed the sky above a crowded city, its place in memory would have been very different. It would have entered history through broken windows, hospital records, official statements, railway interruptions, newspaper sketches, photographs, and the repeated testimony of thousands of people standing under the same morning. It might have been named within hours. It might have become a national tragedy before the day ended. The world would not have had to wait for the forest to speak. But Tunguska happened where the human archive was thin, and that changed the way the event survived. The land absorbed the violence first. Human institutions followed slowly, from far away across distance that was physical, political, and scientific at the same time. This does not make the event more mysterious in a supernatural sense. It makes it more historically delicate. The facts had to pass through layers, through frightened bodies, through local memory, through reports that travelled unevenly, through years of delay, and finally through investigators trying to read a damaged landscape after the sharpest evidence had already begun to fade. In this way, Tunguska shows us that knowledge is never separated from place. A thing can happen with enormous power and still arrive in history quietly, because the place where it happens controls how it is recorded. Siberia did not erase Tunguska. It preserved it differently. Instead of immediate certainty, it offered scattered testimony and a forest pattern. Instead of a central monument, it gave a wide zone of fallen trees. Instead of one clean object to hold in the hand, It gave an absence that had to be interpreted. That difference is why the title of the story still feels unsettled. Something flattened tens of millions of trees, but the first record was not built from instruments surrounding the event. It was built from traces left afterward. Human beings have lived with that kind of evidence for most of our existence. Before cities, before writing, before organized science, people understood disasters through memory, landscape, and repeated experience. A river that suddenly changed course might become a story of danger. A mountain that smoked might become a place of warning. A bright object crossing the night sky might become a sign whose physical cause could not be separated from fear or meaning. Those older responses were not foolish. They were human attempts to live within a world that often acted faster than explanation. Tunguska sits strangely close to that ancient condition. It occurred in an era that could, in theory, investigate it, yet it first reached people as sensation, rumour, and damage. The modern world was present, but not close enough. That tension is central to the story. The event belongs to 20th century science, but its first hours belong to the deep human past. Light, sound, heat, trembling ground, and a mind trying to survive before it could understand. The geography of Tunguska also protects the story from becoming too simple. It reminds us that nature does not choose convenient places for human comprehension. A falling object, a pressure wave, or a sudden atmospheric explosion does not wait for a city, a laboratory, or a clear camera angle. It happens according to physical conditions, not according to the needs of historians. The Earth receives the event wherever it arrives. Only afterward do people ask whether there were enough witnesses, enough records, enough surviving marks to build a confident account. In Tunguska, there were enough marks to know that something extraordinary occurred, but not enough immediate records to close every question. That is a narrow and important distinction. It keeps the story honest. The mystery is not an invitation to believe anything. It is a reminder that even real evidence can be incomplete. A flattened forest can tell us about direction and force, but not every detail of origin. A witness can tell us what was seen and felt, but not every physical process hidden in the sky. A delayed expedition can map damage, but it cannot return the world to the exact second when the air became violent. By the end of this stage of the story, Tunguska is no longer just a remote explosion. It is a meeting between Earth, sky, and the limits of human recording. It asks us to notice how much of history depends on where people are standing when something happens. It asks us to remember that our species began as a listener to landscapes, long before it became a maker of instruments, and it leaves the forest in its proper role, not as a solved answer, not as a stage for fantasy, but as the first surviving witness to a morning when the sky entered the record through broken trees. Witnesses are powerful, because they bring an event back into the scale of a human body. A flattened forest can feel almost too large to imagine, but a person remembering heat on the face, a trembling wall, or a sound arriving across the land gives the mind something smaller to hold. Around Tunguska, the people who later spoke about that morning did not offer the kind of evidence a modern instrument would provide. They offered experience. Some accounts describe a bright light moving across the sky. Some describe a sudden warmth, as if the air itself had opened and released heat. Some describe loud reports, one after another, or a shock that threw people down, shook buildings, frightened animals, and made the ground seem unstable. Farther away, the event was still felt as vibration and sound, a sign that the force had moved beyond the forest itself. These memories matter, but they must be handled gently. A witness can tell us what the world felt like from one place at one moment. A witness cannot always tell us what the object was, how high it was, what it was made of, or exactly how it broke apart. The human nervous system is not a measuring device. It is older than measurement. It evolved to react quickly to light, pressure, heat, and danger, because survival often depended on movement before explanation. In that sense, every witness to Tunguska stood inside a very ancient human situation. Something immense happened. The body knew before the mind could name it. This is close to how our ancestors met sudden events for hundreds of thousands of years. A flash in the sky, a roar beyond the ridge, a wave of hot wind, an animal herd scattering without warning. These were not puzzles to solve calmly. They were signals that demanded attention. Later, around a fire or in a shelter, the mind could begin to arrange memory into story. That arrangement helped people share danger, but it also meant that memory was never a perfect recording. Tunguska asks us to respect testimony without forcing it to carry more weight than it can bear. The witnesses tell us that the event entered human life with violence. They help confirm that the sky brightened, the air shook, and the shock reached far beyond the damaged center. But they do not close the question. They open it from the human side. Their words are especially valuable because the land was remote and instruments were few. When a modern city experiences a sudden explosion, many forms of evidence overlap. Clocks, cameras, broken glass, hospital logs, pressure readings, news reports, and thousands of separate viewpoints can be compared. Around Tunguska, human memory had to do more work. That does not make the memory false. It means memory must be placed beside the forest, not above it. The fallen trees, the delayed investigations, the regional reports, and the witness accounts all belong together, each one incomplete alone. One person may remember the heat more clearly than the sound. Another may remember the sound more than the light. A person nearer the path may describe the event differently from someone farther away. Even the direction of a bright object can be difficult to preserve in memory when fear enters the body. The mind turns toward survival, not geometry. This is why science does not simply collect the most dramatic account and treat it as the whole event. It compares many accounts, looks for what overlaps, and then checks those overlaps against physical traces. The strongest details are not always the most vivid ones. Sometimes the quiet agreement between separate memories matters more than one striking description. Tunguska became a story carried by people who had not chosen to witness history. They were working, traveling, resting, tending animals, or moving through ordinary morning life when the sky interrupted them. For them, the event was not a mystery title. It was heat, sound, fear, and a changed world. For us, their memories are a doorway, but not the room itself. They remind us that before any scientific diagram, there was a human being looking up, feeling the air shift, and trying to understand why the familiar sky had suddenly become strange. A strange feature of many Tunguska memories is that they seem to unfold in layers. First there is light, then heat, then movement of air, then sound, as if the event reached the body through different doors at different speeds. That order is important, not because every account matches perfectly, but because it reminds us that a human witness does not receive a disaster as one complete fact. The eye, the skin, the ear, and the ground each tell their own story. Light arrives almost immediately. Sound takes longer. A pressure wave moves through air and objects. Fear arrives everywhere at once, changing how time is felt. Someone who saw brightness in the sky may have had a few moments before the noise reached them. Someone indoors may have known the event first through shaking walls, broken objects, or a sudden sense that the earth itself had moved. Someone with animals may have remembered not only the sky, but the behavior of living creatures around them. In that way, the event entered the human world as a sequence of sensations, not as a clean explanation. The mind later tries to place those sensations in order, but the original moment was not calm enough to be arranged like a diagram. For people in the region, the sky had not merely displayed something unusual, it had crossed into ordinary life with force. A person could be sitting near a dwelling, walking through open ground, working with animals, or preparing for the day, and suddenly the body would become the first instrument. The skin might report heat, the ears might report a crash, the legs might report the ground shifting, the chest might report pressure before words arrived. Such testimony matters because it preserves the scale of the event in human terms. A scientific estimate may describe energy, distance, or altitude, but a witness tells us that an event in the sky became something a human nervous system had to endure. Yet the same human scale also creates limits. A person thrown into fear may misjudge direction. A flash may seem nearer or farther than it was. A sound rolling across hills and forest may seem to come from more than one place. A memory repeated years later may keep its emotional truth while losing some physical precision. That does not make the memory useless. It means the memory must be treated as living evidence, not mechanical evidence. Human memory is shaped for meaning and survival. It is not shaped to preserve angles, velocities, or chemical composition. For most of our species' existence, that was enough. Early humans did not need to calculate the speed of a falling object to understand danger. They needed to notice that the sky had changed, that animals were alarmed, that fire or falling debris might threaten a camp, that moving away could be wiser than standing still. The Tunguska witnesses, though living in the modern age, were placed for a few moments in the same ancient relationship with nature. They could experience, react, remember, and tell. Explanation would come later, and it would come from comparing their memories with the damaged forest. One witness alone could not define the event. Many witnesses, separated by distance, could begin to form a rough human map. If several people remembered brightness, if several remembered intense sound, if several remembered shaking, then those shared features became harder to dismiss. But shared features still had to be placed beside the physical record. The fallen trees showed direction and force in a different language. The absence of an ordinary crater complicated the story in yet another language. The witness accounts gave the event warmth, terror, and immediacy, but the forest gave it shape. Neither one was complete without the other. A careful listener can sense why Tunguska has remained so durable in memory. It is not only because trees fell, it is because people were there close enough to feel the sky behave like something solid. The atmosphere, which usually carries breath, weather, and sound, became a medium of destruction. That is a deeply unsettling thought, but it is not fantasy. It belongs to the real vulnerability of life on Earth. Human beings evolved beneath an atmosphere that protects us from many small objects entering from space. Yet that same protective layer can transform incoming energy into a violent airburst before anything reaches the ground. A witness does not need to know that process to feel its result. They only know that the air has struck. In the deeper history of humanity, countless people must have watched strange lights, meteor showers, distant impacts, volcanic glows, or atmospheric events without any framework close to modern science. Some memories may have become warnings. Some may have become sacred stories. Some may have vanished when the last person who carried them died. Tunguska is one of the rare cases where the old human experience of the sky can be placed beside later investigation. The witnesses did not solve the event, but they kept the morning from becoming only a pattern of dead wood. They remind us that the mystery began not in an abstract debate, but in bodies startled awake by light, heat, pressure, and sound. When the witness accounts are placed together, they do not form a perfect picture. They form something more human, a broken circle around an event too large and too fast for any one person to hold. One person may remember a pillar or streak of light. Another may remember the heat. Another may remember the sound, arriving with such force that ordinary objects suddenly seemed fragile. Another may remember animals reacting before people understood what had happened. These accounts do not need to be identical to be valuable. In fact, their differences tell us something important. Tunguska was not witnessed from one seat in a theatre. It was experienced from scattered points across forest, river, settlement, and open ground. Each witness stood at a different distance, under a different angle of sky, inside a different moment of fear. The event itself may have lasted only a short time, but memory had to carry it for years. That is why the testimony should be read like a constellation rather than a single line. Each account is one star. Alone, it shines but does not explain. Together, the pattern begins to appear, though the dark spaces between them remain. This is often how human knowledge begins. Our species did not evolve by receiving complete truths. We evolved by comparing partial signs. One hunter saw tracks near water. Another noticed broken grass. Another heard alarm calls from birds. Another smelled smoke or rain before seeing either one. Survival came from joining fragments without pretending that a fragment was the whole world. Tunguska asks for the same discipline. The witnesses give us fragments of brightness, heat, sound, pressure, and fear. The forest gives us fragments of direction, breakage, and scale. The absence of an obvious crater gives us another fragment, quieter but deeply important. None of these fragments should be forced beyond what they can honestly carry. A witness saying that the sky burned does not prove the exact nature of the object. A witness hearing explosions does not alone tell us how the energy was released. A witness feeling heat does not by itself measure distance or temperature. But when these experiences are set beside the flattened trees, they help show that the event was not a local fire, not an ordinary storm, not a slow ecological death. It was sudden, atmospheric, and powerful enough to enter both land and memory. That is the careful ground on which the story can stand. The deeper lesson is that eyewitness memory is neither something to worship nor something to dismiss. It is one of the oldest forms of evidence humans possess. Before writing, before science, before instruments, the memory of witnesses was how communities carried danger forward. A child might learn where ice breaks, where floods rise, where lightning strikes, where animals gather, where a slope gives way after rain. These memories were imperfect, but they were useful. They allowed human beings to survive in landscapes that were never fully predictable. Tunguska belongs partly to that ancient inheritance. People saw and felt something, then carried it into language. Later, science returned to the place and asked what parts of that language matched the physical world. This meeting between memory and measurement is one of the most important parts of the event. It keeps the witnesses from becoming mere decoration in a mystery story. They are not there to make the event sound dramatic. They are there because the first record of the sky's violence passed through human bodies. Without them, Tunguska would be colder. A map of fallen trunks, a delayed expedition, a pattern in a remote forest. With them, it becomes a human encounter with a force that arrived before understanding. Still, care is necessary. The mind under shock may compress time. It may enlarge sound. It may place meaning around a flash before the facts are known. Memory can preserve truth and change shape at the same time. A person may be entirely honest and still remember an angle incorrectly. A story may be sincere and still grow sharper or simpler as it is repeated. This does not make people unreliable in a moral sense. It makes them human. The body's first task is not to become an archive. Its first task is to live. That simple fact connects Tunguska to the earliest human beings more directly than it first appears. Long before any written history, our ancestors lived beneath the same sky, with the same vulnerable senses, the same need to turn sudden fear into shared memory. They could not know the chemical nature of a meteor, or the structure of the atmosphere, or the physics of pressure waves, but they could know that something had happened, that the world had changed, that a place was no longer the same. In Tunguska, modern people briefly met the old condition again. The sky acted, the body reacted. Memory gathered what it could. An explanation came only afterward. By the end of the witness story, the event is not solved, but it is no longer distant. It has entered the human scale. We can imagine someone looking up too late, feeling warmth where there should have been only morning air, hearing a sound roll across the land, and then trying for the rest of life to describe a moment that had no ordinary name. After the morning violence passed, the forest did not immediately become a laboratory. It became quiet again. Birds returned where they could. Insects moved through broken wood. Rain fell on scorched bark. Snow came with the next cold season, covering trunks that had been thrown down by a force no one nearby could fully name. The land began doing what land always does after disruption. It absorbed, concealed, softened, and slowly changed the evidence. This is one of the most important parts of the Tunguska story, because the event itself was sudden but the human investigation was not. There was no large scientific team standing ready at the edge of the damage zone in the days after the blast. There were no aircraft circling above with cameras. There were no satellites watching the forest from orbit. There was no immediate recovery of a clear object that could be placed on a table and studied under glass. Instead, there were reports, memories, scattered concern, and a remote landscape already beginning to move away from the exact condition of that first morning. To understand this delay, it is necessary to remember the world around 1908. Siberia was vast, difficult to cross, and only partly connected to the institutions that could organize fast scientific work. Travel into remote taiga was slow and demanding. Rivers, bogs, insects, weather and distance all mattered. A map might show a route, but the body had to carry that route through mud, cold, hunger, and uncertainty. Then history itself grew heavier. The years after Tunguska were not calm years. The Russian Empire moved through crisis, war, revolution, and civil conflict. Scientific curiosity did not disappear, but the ability to organize a difficult expedition into a remote, damaged forest was shaped by money, politics, transport, and survival. The Earth had received a violent event in seconds, but the human world needed years before it could return with enough attention to read the wound carefully. This delay changed everything. A fresh landscape is different from an old one. Heat marks fade or become confused with later fire. Fallen trees rot, shift, or are covered by moss. Smaller fragments, if they existed on the surface, could sink into wet ground, be scattered, be missed, or be altered by weather. Human memory also changes. A witness may remain sincere, but years can smooth some details and sharpen others. The first shock becomes a story, and stories become easier to tell than the raw confusion of the moment. That does not make the later evidence worthless. It means the evidence had to be approached with humility. The scientists who eventually entered the region were not stepping into the event itself. They were stepping into its aftermath, and an aftermath is always a translation. This connects Tunguska to the oldest problem in human knowledge. We rarely meet the past directly. We meet what the past has left behind. Archaeologists do not hear the first language spoken around an ancient hearth. They find ash, stone, bone, pollen, and marks in soil. They do not see the first person who shaped a tool. They see the tool after hands, weather, burial, and time have all worked upon it. Tunguska, though modern, became similar in this way. The main event was gone. What remained was a landscape of clues. A broken forest is like an archaeological site written in wood instead of stone. It can be read, but it cannot be forced to confess more than it holds. The long silence before close investigation also affected imagination. When people do not have firm measurements, the mind begins to fill the space. That is natural. Human beings dislike gaps, especially when the gap surrounds danger. A powerful blast without an obvious crater invites questions. Questions invite stories. Stories can become useful if they lead to careful inquiry, but they can also become misleading if they race ahead of evidence. Tunguska's delay gave both science and speculation time to grow. The careful path is to separate them. The delay explains why some details remain uncertain, but it does not erase the physical reality of the event. The forest still showed a large pattern of destruction. Witnesses still preserved the human experience of light, heat, sound, and shock. Later investigations still found a scene unlike ordinary forest damage. What was missing was not the event, but the perfect moment of observation. For most of human history, that perfect moment almost never existed. Our ancestors lived in a world where disasters were noticed after they began, and understood only afterward, if at all. A flood arrived before anyone could write its cause. A drought shaped generations before anyone could measure climate. A strange light crossed the sky and vanished before anyone could preserve it except in memory. Tunguska stands in that same long human shadow. It happened close enough to the modern world that science could return, yet far enough from immediate observation that the first and best evidence had already begun to fade. The silence after the blast was therefore not empty. It was filled with slow change, trees decaying, people remembering, institutions struggling, and a question waiting in the forest until someone could finally come close enough to ask it properly. The first major scientific journey into the damaged region was not a simple walk toward an answer. It was a movement through delay itself. Years had passed, and the forest that waited for investigators was no longer the forest of the first morning. It was the same place but altered by seasons, rot, fire, water, insects, and the slow work of living ground. When scientists finally began to examine the area with serious attention, they were not collecting a fresh event. They were reading an old wound. That difference matters, because every natural trace has a lifespan. A broken tree may preserve direction for a long time, but its smaller branches decay. Bark burns, peels, or falls away. Soil freezes and thaws. Moss covers the ground like a quiet second skin. Water can move small material from one place to another. If tiny fragments existed, they could become difficult to separate from the ordinary mineral dust. plant remains, and debris of a forest floor. Even the most patient investigator had to face a simple truth. The landscape had continued living after the blast. It had not remained still for science. This is one reason Tunguska is not only a question about force, but a question about time. The event happened in seconds, yet the evidence was gathered across years. The physical world did not pause between those two scales. It changed. Human memory changed too. Witnesses could still describe what they had seen and felt, but the moment had passed through fear, retelling, and ordinary life. A person might remember the light vividly and forget the exact direction. Another might remember the sound more clearly than the order of events. A family might repeat a story until it became stable in meaning, even if some physical details became less precise. This is not a failure unique to Tunguska. It is how memory works when the body survives something too sudden to understand. In the deep past, nearly all human knowledge of rare disasters must have passed through the same fragile path. A sudden flood, an eruption, a falling object, a sky brightened at night. These events could shape lives, migrations, fears, and stories, but the exact cause might vanish before anyone could preserve it in a durable way. Tunguska happened in a world with science, but the first record still belonged partly to that older human condition. By the time trained observers arrived, they had to combine what people remembered with what the forest still showed. Neither source was complete alone. The forest offered patterns, especially the direction of fallen trunks across a wide area. Witnesses offered the lived sequence of light, heat, pressure, and sound. The absence of a clear crater offered another clue, but also another difficulty. Together, these pieces did not create a perfect picture. They created a careful boundary around the event. Something extremely powerful had occurred above or near the surface. The force had moved through the air with enough strength to flatten trees over a huge region. The scene did not match an ordinary storm or a slow natural death of woodland, but the longer investigators looked, the more important caution became. A dramatic landscape can tempt people to dramatic certainty, yet careful science often moves in the opposite direction. It asks what can be known, what can be inferred, and what must remain uncertain. Tunguska needed that kind of discipline. The delay had made some questions harder. It had not made all answers impossible, but it had removed the comfort of immediate proof. There was no single surviving object that could carry the whole explanation. There was no fresh crater with edges untouched by weather. There was no complete chain of instruments from sky to ground. Instead, there was a damaged forest slowly becoming forest again. This is a quiet but important image. Nature can preserve evidence and erase it at the same time. A tree can fall in a direction that records force, while its wood decays in a way that hides finer details. Soil can hold particles, while also mixing them with older and newer material. A witness can preserve fear, while time blurs geometry. Human beings have always had to live inside that mixture. We learn from remains, but remains are never the event itself. In Tunguska, the long delay before close investigation did not create the mystery from nothing. It shaped the mystery that the event had already left behind. It made the questions slower, softer at the edges, and harder to close. The forest had not forgotten, but it had begun to speak in a quieter language. What made the silence after Tunguska so important was not simple neglect. It was the way history itself can stand between an event and its explanation. A blast may happen in a moment, but investigation belongs to a human world of roads, funding, politics, weather, fear, and attention. After 1908, that human world was unstable. The Russian Empire was already strained. Within a few years, Europe moved toward war. Then came revolution, civil conflict, famine, and the reorganization of institutions that once might have supported a difficult scientific journey. In that setting, a remote forest explosion did not disappear, but it could not easily become the first priority of a wounded society. This is not difficult to understand. Human beings often turn toward the dangers closest to them. A family facing hunger does not begin with the sky. A government under pressure does not always send resources into distant swamp and taiga. A scientist may have questions, but questions need time, money, safety, and permission before they can become fieldwork. Tunguska waited inside that gap. The forest carried the evidence while human history passed through violence of its own. This gives the event a strange double meaning. On one level, it was a natural event, a sudden release of energy over a remote landscape. On another level, it became a historical event, shaped by the conditions of the people who tried to remember and study it. The delay was not an empty pause. It was filled with other human emergencies. That is why the eventual investigation has to be seen with respect. To enter that region years later and still recover a meaningful pattern was not a small achievement. Investigators had to treat the forest almost as an archive without pages. They had to ask which trees had fallen outward, which had remained standing nearer the centre, which marks belonged to the original blast and which might belong to later fire or decay. They had to compare stories from witnesses who had lived with their memories for a long time. They had to move through land that did not make travel easy and did not preserve evidence in neat containers. Their work was not the clean discovery of a single object. It was the slow assembly of many incomplete signs. This is how much of the past is known. The earliest human story is not preserved as a complete memory either. It comes to us through bones, stone tools, ancient footprints, traces of fire, pollen in sediment, and marks that must be interpreted with caution. We know that early humans moved, adapted, made tools, ate, feared, learned, and died. But we do not know every voice, every decision, every night of hunger, every moment of wonder beneath an unfamiliar sky. The further back we look, the more we depend on remains that survived by chance. Tunguska, though far closer to us in time, carries the same lesson. An event does not become fully knowable simply because it happened in the modern era. It must still be caught, measured, preserved, and compared before time can blur it. When that does not happen immediately, science must work with what remains. The careful strength of science is not that it pretends the missing pieces are present. Its strength is that it names the missing pieces and still asks what the surviving evidence allows. In Tunguska, the surviving evidence allowed a great deal. It allowed people to see that the damage was immense. It allowed them to recognize a pattern in the fallen forest. It allowed them to understand that the force had not behaved like an ordinary ground explosion, storm, or forest fire. It allowed them to compare witness memories with physical traces. But it did not give everything. It did not give a clear crater. It did not give a large, obvious fragment that could end the argument by its weight alone. It did not give an unbroken recording of the object's path, height, composition, and final moments. Those absences are not failures of imagination. They are limits created by place and time. To accept those limits is not to weaken the story. It makes the story more honest. The long silence before science arrived teaches a quieter truth than spectacle can offer. Human beings often meet reality late. We arrive after the flash, after the fear, after the first marks have begun to fade. Then we bend down and read what is left. Sometimes what is left is enough to build a strong explanation. Sometimes it is enough only to build a careful boundary around uncertainty. Tunguska lives in that boundary. It is not a blank mystery, and it is not a closed book. It is a reminder that the world can act with enormous speed, while understanding must travel slowly through forest, memory, and history. The forest was not only destroyed, it was arranged. That is one of the quiet facts that makes Tunguska different from a vague story of damage. A storm can break trees, but it usually leaves the memory of wind moving across the land in one broad direction. Fire can kill a forest, but fire often climbs, spreads, pauses, and follows fuel, slope, dryness, and weather. Disease can weaken trees slowly, unevenly, in patches of time. At Tunguska, the fallen trunks suggested something more sudden and more centered. Across a wide region, trees lay with a kind of rough outward order, as if force had moved from a central area and pushed the forest away from it. This does not make the forest an easy answer. Trees are living things, not measuring rods placed by engineers. They differ in age, height, root strength, water content, and position in the ground. A young tree bends differently from an old one. A tree rooted in wet soil falls differently from one gripping stony earth. A tree already weakened by cold, insects, or rot might break under less pressure than a healthy trunk beside it. Yet when thousands upon thousands of trees fall in related directions, the individual differences begin to become a pattern. That pattern is why the forest became the most important surviving witness. It did not say what the object was. It did not give a chemical signature by itself, but it showed that energy had entered the landscape in a way that could be mapped. For a careful investigator, a fallen tree is not merely a dead tree. It is a line drawn across the ground. Its roots mark where it once stood. Its crown points toward where it was driven. Its broken trunk carries the memory of pressure. Multiply that by an entire forest, and the land begins to resemble a huge, damaged compass. Near the center, reports describe trees that could remain standing while stripped of branches, scorched or killed. A strange image because one might expect the very center to be the most completely flattened. But if force descended from above and spread outward, the pattern becomes less simple than a wave traveling along the ground. The air itself must be imagined as part of the event. Not empty space, not merely background, but a medium that received energy and transmitted it into wood, soil, water, and bodies. This is a difficult thought because human beings usually experience air as gentleness, breath, wind, weather, the coolness before sleep. Yet air under sudden pressure can become hard enough to break, throw, and flatten. The people who lived through the morning felt that truth in their bodies. The trees preserved it in their fall. In human history, learning from such traces is an ancient skill. Long before anyone could calculate pressure waves, people watched how reeds bent after storms, how ash lay after fire, how branches broke where animals passed, how smoke moved in wind, how snow held footprints before melting. Our species became intelligent not only by thinking inwardly, but by reading outward signs. The land was the first record. Tunguska belongs to that old habit, but enlarged almost beyond comfort. Instead of one footprint, there was a whole forest of directional marks. Instead of one broken branch, there were millions of broken or fallen trunks. The scale was modern in its shock, but the method of knowing was ancient. Look at what remains, compare one mark to another, and resist the urge to claim more than the marks allow. The outward pattern mattered because it pushed the story away from ordinary explanations. If the damage had been random, one might imagine a mixture of local fires, weather, and later decay. If the trees had fallen in one broad direction, one might look first toward wind. If the center had been a deep hole, one might begin with an object striking the ground directly. But Tunguska gave something harder to simplify. Broad flattening, outward direction, intense force, and no ordinary crater to anchor the eye. The forest was therefore both evidence and obstacle. It helped show that the event had a center, but it did not provide the familiar center people wanted. It helped show that air carried destructive energy, but it did not reveal every step by which that energy had been released. It offered geometry without complete biography. This is why the damaged trees must be approached slowly. They are not props in a mystery. They are the closest thing the Earth left to an instrument inside the event. Each trunk recorded one small meeting between force and life. Together, they made visible something that had already vanished from the sky. And because they stood in Siberia, far from immediate measurement, they carried a burden that no forest was made to carry. They became the map of an invisible violence. The pattern of fallen trees at Tunguska is often described from above, as if a person could float over the taiga and see the whole design at once, but no one living inside the forest could experience it that way. On the ground, the pattern would have been broken into fragments. One trunk across another, roots lifted, branches tangled, dead wood pointing through moss, open spaces where a standing forest had once softened the light. To understand the force, investigators had to move from fragment to fragment and imagine the larger shape slowly. This is important because the forest did not give one dramatic sign. It gave many small signs repeated across a huge area. A single fallen tree can be misleading. It may have been weak. It may have grown in shallow soil. It may have been struck by another trunk as it fell. But when the directions of many trees are compared, the scattered marks begin to form a kind of language. The language is not exact, but it is not silent. It says that the force was not ordinary wind moving evenly across the land. It says that the destruction had a relationship to a central region. It says that air, pressure, and direction must all be considered together. That is why the forest became more than a damaged place. It became a physical record of something that had already disappeared. Nearer the centre, the pattern became more difficult and more revealing. Some accounts from later surveys describe trees still standing upright while stripped of branches, as if they had been burned or shocked from above rather than simply pushed sideways. This image is often called strange, but it is strange only if we expect the event to behave like a simple ground-level blast. Nature is rarely that simple. A force released above the surface can strike downward, spread outward, reflect, weaken, strengthen in certain directions, and interact with hills, valleys, wet ground, and the uneven strength of living wood. The result can look contradictory at first. Trees flattened in one zone, trees standing damaged in another, burns in some places, less damage in others. But contradiction is not always a sign that evidence is useless. Sometimes it is a sign that the event was three-dimensional, not flat. It happened in the sky and the air before it became a pattern on the ground. Human beings often prefer causes we can see and touch. A stone in a crater feels satisfying because it gives the mind a center. Tunguska gave a center made of effects, not a center made of an object. That is harder to accept. It requires thinking of energy as something real even when the object that carried it is gone. In the deepest human past, this kind of thinking would have been very difficult. Our ancestors could track animals because bodies left prints. They could understand fire because flame left ash. They could understand a broken tool because the stone remained in the hand. But the sky often gave signs without leaving the thing itself. A streak of light vanished. Thunder rolled and disappeared. A meteor burned away before touching the ground. For most of human history, people lived among effects whose causes were only partly visible. Tunguska, despite happening in a scientific age, returned that problem to modern minds. The trees were there. The force was obvious. But the agent was not lying clearly at the centre. The forest pattern also shows why slow observation matters. A person looking quickly might only see ruin. A person looking carefully begins to separate ruin from arrangement. Which trees point away from the centre? Which lie across others? Which appear burned? Which remain standing but dead? Which parts of the land were shielded by terrain? Which damage came from the first event, and which came later from weather or fire? These questions do not create instant certainty. They create discipline. They prevent the imagination from rushing too quickly. The forest asks the observer to move at the pace of evidence. That pace is slower than fear and slower than curiosity, but it is the only pace that protects truth. In a sleep story, this may seem like a quiet lesson, yet it is central to the whole question. The title speaks of millions of trees flattened in seconds, but the true meaning of that number is not only scale, it is repetition. The same force met tree after tree after tree, each one slightly different, each one answering in wood, roots, splinters and direction. The event wrote itself millions of times, but none of those writings was complete alone. Together, they formed a rough map of invisible pressure, and because the map was made of living things, it also carried loss. A forest is not just a collection of vertical lines. It is shade, shelter, soil, insects, birds, animals, fungi, water, and time. When such a forest falls at once, it is not only matter being moved, it is an ecosystem being forced into a new shape in a moment shorter than memory can comfortably hold. That is the coldness at the centre of Tunguska. The sky did not need to leave a crater to change the ground. It needed only to turn energy into air, and air into force, and force into the sudden direction of fallen trees. The fallen forest gave investigators one of the strongest kinds of evidence a vanished event can leave, a pattern repeated across space. Yet even a strong pattern has limits. It can show direction, scale, and the movement of force, but it cannot always name the source with certainty. This is the careful boundary around Tunguska. The trees could say that something had acted upon them quickly. They could show that the damage spread from a central region. They could suggest that the air itself had carried violent pressure outward, but they could not, by themselves, identify the exact body that entered the atmosphere, the precise height at which energy was released, or every detail of what happened in the seconds before the forest fell. A tree records the force that reaches it, not the full journey of that force through the sky. This distinction matters because it protects the story from becoming too simple. A flattened forest is powerful evidence, but it is not a confession. It must be read beside witness memories, later surveys, the missing ordinary crater, and what is known about objects entering Earth's atmosphere. The forest is therefore not the end of the question. It is the ground from which the question becomes serious. In many ways, this is how human beings have always learned from the world. The earliest people did not receive complete explanations from nature. They received marks: a broken shell near a hearth, a path pressed into mud, a cut mark on bone, a layer of ash beneath soil, a sudden absence of animals from a valley. From such signs they learned caution, memory, and pattern. Tunguska belongs to that same long habit of reading the earth after the moment itself has passed. The difference is scale. Here, the sign was not a footprint or a tool edge, but a forest reorganized by pressure. Millions of living trunks had become directional evidence. The land had been turned into a rough diagram of invisible energy. Still, even a diagram needs interpretation. If the event had left a deep crater, people might have centered their understanding there. If it had left a large fragment, they might have held the object in their hands and asked fewer questions about its identity. But Tunguska left its clearest message in wood, and wood is both revealing and fragile. The fallen trees could preserve the shape of destruction, while time slowly removed smaller clues. The roots, trunks, and burned surfaces showed that something extraordinary had happened, but they also reminded investigators that the forest was not frozen at the instant of disaster. It kept changing. It decayed, grew over, burned in later fires, and entered ordinary ecological time again. That gives the scene a quiet sadness. The very life of the forest, the thing that allowed recovery to begin, also made some evidence less certain with each passing season. A scar can heal over, a trunk can rot, a burned surface can be confused by later flame. A disturbed patch of soil can be mixed by water, frost, roots, and animals. The earth preserves and erases in the same gesture. This is why the Tunguska forest must be treated as a witness with a fading voice, not a machine that recorded every number. Its testimony is real, but it is not unlimited. What it tells most clearly is that the event was sudden, directional, and immense enough to make air behave like a physical blow. That lesson alone is important. It changes how the mind sees the sky. The atmosphere is often imagined as protection, and in many ways it is. It burns small incoming objects, softens temperature, carries weather, and holds the breath of living beings. But under rare conditions, the atmosphere can also become the place where destructive energy is released before anything strikes the ground. The result can be a wound without the familiar shape of impact. That possibility sits at the center of Tunguska, but it should be approached slowly, because a possibility supported by evidence is not the same as a completed picture. The forest points toward a powerful event in the air. It does not tell every hidden detail of the object that produced it. For the people who later tried to understand the scene, the work was almost an act of translation. They had to translate fallen wood into direction, direction into pressure, pressure into an event above the ground, and then compare that event with what witnesses remembered. Every translation carries uncertainty. Yet uncertainty is not emptiness. It is the space where careful thinking lives. By reading the forest as a map of force, Tunguska becomes clearer without becoming fully closed. The trees teach us that a mystery can be narrowed honestly. They show that not every unanswered question is wide open, and not every missing object invites fantasy. Sometimes the world leaves enough evidence to guide the mind, but not enough to let it rest completely. In that balance, the fallen forest remains the central witness, silent, damaged, incomplete, and still more truthful than any story that tries to make the mourning easier than it was. The missing crater is one of the reasons Tunguska still holds the mind so strongly. When people imagine a violent object arriving from the sky, they often imagine a hole in the ground. The picture feels natural. A stone falls, the earth receives it, soil and rock are thrown aside, and a circular wound remains. A crater gives the eye a center. It gives the story a place to stand. It lets the mind say, this is where the force entered. But Tunguska did not offer that simple comfort. The forest had been damaged on a scale that no ordinary local event could explain, yet the land did not present a clear, deep impact scar matching the scale of destruction. There were fallen trees, scorched surfaces, broken trunks, witness accounts, and a vast pattern of pressure, but not the familiar bowl that would make the event easy to place in human imagination. This absence does not mean nothing came from the sky. It means the event did not behave like the most familiar image of a solid body striking the ground. That distinction is essential. A crater is not the only way the Earth can be struck. Energy can be released before an object reaches the surface. A body moving through the atmosphere at great speed can meet resistance so violently that the air itself becomes part of the event. Pressure rises, heat builds. The object may fragment, burst, or lose much of its energy high above the land. If that happens, the ground below can still be devastated, even if no large single piece survives to carve a classical crater. The forest can be flattened by the blast wave rather than by a stone ploughing into the soil. This does not solve every detail of Tunguska, but it explains why the absence of a crater is not an empty clue. It is a clue pointing away from a simple ground impact and toward a more complex event in the air. For human beings, this is a difficult idea because our senses trust objects more than energy. We understand the hammer because we can hold it. We understand the footprint because we can see the foot that made it. We understand a broken branch because something solid must have pressed or struck it. But energy released in the air is harder to picture. It arrives as brightness, heat, pressure, and sound. Then it vanishes, leaving effects without leaving the same kind of visible body. In this way, Tunguska touches a very old limit in human understanding. Our ancestors learned the world through contact, weight, shape, and trace. A tool remained after use. A bone remained after a meal. Ash remained after fire, but the sky often gave events that did not stay. Lightning flashed and disappeared. Thunder rolled away. Meteors burned and were gone before anyone could approach them. A bright object could cross the night and leave only fear, wonder, or a story. Tunguska, though studied in a scientific age, returned modern people to that older puzzle. How do we understand a cause when the cause does not remain in the ordinary form we expect? The missing crater also made the forest more important. Without a single central hole, the pattern of fallen trees had to carry more meaning. Investigators had to ask where trunks pointed, where damage weakened, where it intensified, and how the force could have moved through the air. The landscape had to be read as a field of effects rather than as a scene centered on one obvious wound. That made the work slower and more uncertain, but also more revealing. The absence of a crater did not erase the event. It changed the kind of evidence that mattered. Instead of asking only what hit the ground, one had to ask what happened above it. Instead of looking only downward into soil, one had to think upward into the atmosphere. The center of the story moved from a hole in the earth to a volume of air that could no longer be touched. This is why Tunguska feels so different from many other impact stories. It is not only about something arriving, it is about something arriving and failing to leave the sign people most expect. The mind meets destruction, then searches for the object, then finds absence where certainty should be. That absence is not mystical, it is physical and historical. It came from the nature of the event, the remoteness of the place, the delay before investigation, and the difficulty of preserving small or scattered material in a living forest. Yet its effect on understanding is profound. A crater would have narrowed the imagination quickly. Without one, the question widened, but not without boundaries. The fallen forest, the witness reports, and the lack of a simple impact scar all leaned toward a story of force released before the ground could receive a single body. Still, the exact identity of that body, its composition, its path, and its final breakup could not be read from absence alone. A missing crater is a powerful clue, but it is not a complete answer. It teaches caution. It reminds us that nature is not required to leave the kind of evidence human beings find easiest. Sometimes the Earth is changed not by a visible object resting at the center, but by an invisible wave that has already passed on. In Tunguska, the whole people expected was missing, and because it was missing, the forest itself had to become the crater's replacement. Broad, broken, directional, and unfinished. The absence of a crater can feel like an empty space in the story, but emptiness can sometimes guide the mind as strongly as presence. A deep impact scar would have told people where to begin. It would have gathered attention into one circle of earth and stone. It would have made the damaged forest seem like the outer consequence of a central wound. Without that circle, Tunguska forces a different way of thinking. The center is not a whole. The center is inferred from effects. It is found by looking at how trees fell, how far the pressure reached, how witnesses described light and sound, and how the damage failed to match a simple collision with the ground. This is a slower kind of evidence, because it does not let the eye rest. It asks the mind to imagine the event as a volume, not a point. Somewhere above the surface, energy was released into the air with enough violence to press the forest downward and outward. The ground suffered, but the main transformation may have happened before the ground could receive the object in the familiar way. That thought changes the emotional shape of the event. A crater belongs to the earth. An airburst belongs to the space between earth and sky. It occurs in the layer where birds fly, clouds form, winds move, and human beings breathe. The same atmosphere that usually softens our world can, under rare conditions, transmit destruction with terrifying efficiency. This does not require fantasy. It requires accepting that air is matter, and matter can carry force. Air seems gentle because we move through it without noticing its weight. But when energy enters it suddenly, it can become a wall, a hammer, a wave. At Tunguska, the fallen trees suggest that the atmosphere was not merely the background of the disaster, it was one of the main actors. The forest did not need to be struck by a mountain of stone. It could be struck by pressure moving faster than any person could escape. For most of human history, such an event would have been almost impossible to understand in physical terms. Our ancestors knew wind could push, storms could break branches, fire could race through dry grass, and thunder could shake the body. But the idea that a body from space might release its energy overhead, leaving devastation without a simple stone at the center, would have had no easy place in ordinary thought. People would have known the experience before they knew the cause. This is why Tunguska belongs not only to the study of one Siberian morning, but to the longer story of human vulnerability beneath the sky. We live on a planet protected by atmosphere, yet that protection is not a perfect wall, it is an active boundary. Small objects burn, larger ones may fragment, rare ones may release energy high enough to spare a crater, but low enough to wound the surface below. The missing crater therefore becomes a sign of process rather than a sign of nothing. It suggests that the event's most important violence may have happened in motion, in breakup, in pressure, in the conversion of speed into heat and shock. Still, caution is necessary. To say that the lack of a crater points toward an atmospheric event is not the same as claiming every detail is settled. The exact nature of the incoming body remains a matter of careful study and debate. Was it more rocky, more fragile, richer in ice, or something whose surviving material became too dispersed to recover easily? How high did it release most of its energy? How did its path shape the pattern below? These are not questions the missing crater can answer alone. Absence narrows the story, but it does not finish it. That is the quiet discipline Tunguska demands. It asks us to resist two opposite mistakes. One mistake is to treat the missing crater as if it means nothing happened in any physical way. The other is to treat it as permission to imagine anything at all. The better path is narrower and steadier. A huge event happened. The forest recorded it. Witnesses felt it. The lack of a simple impact scar changed the explanation, but each clue must remain tied to what it can actually support. In the early human world, this kind of restraint may not have been possible in the same form, because survival often needed meaning faster than evidence could provide. A strange sky event might become warning, omen, memory, or sacred fear. Modern science offers a different gift. It does not remove uncertainty entirely, but it teaches us how to live with uncertainty without filling it too quickly. Tunguska's missing crater is a lesson in that gift. It is not a blank. It is a shape made by what did not remain. It turns the eye away from a hole in the ground and upward toward the air, where the most violent moment may have passed without leaving a solid body behind. A crater would have made Tunguska easier to imagine, but the absence of one made it more useful to think with. It forces the story away from the simple picture of a stone striking soil and towards something less visible. Energy released into the air, pressure moving through a forest, and a landscape changed by a force that did not leave its body behind. That is why the missing crater is not a decorative mystery. It is central to the whole event. It changes the question from where did the object hit to how did the force arrive. Those are very different questions. One points downward into the ground, the other points upward into the atmosphere, into the final seconds of a body moving faster than human senses can follow. The forest below became the surface where that invisible process was written. Trees fell, but they did not fall into a single hole. They fell across distance, in relation to pressure, direction, height, and release of energy. The missing crater therefore teaches a quieter kind of thinking. It asks us to stop expecting nature to leave evidence in the shape most convenient for us. A human mind likes centers. It likes a wound it can circle, measure, photograph, and name. It likes an object that can be picked up, weighed, and placed in a museum drawer. Tunguska did not provide that comfort. It left a center that had to be inferred. It left a cause that had to be reconstructed from effects. In this way, it resembles many parts of the human past. The oldest events that shaped our species rarely survive as complete scenes. We do not see the first fear, the first warning cry, the first night when a group looked upward and saw something burn across the sky. We find traces, ash, tools, bones, footprints, layers of soil, marks that mean more when compared carefully. Tunguska is much younger than those deep human beginnings, but it reminds us of the same discipline. To know the past, we often have to work backward from what remains. The lack of a crater also keeps the event from being misunderstood as nothing more than an impact story. The important thing may not have been a collision with the ground, but a transformation before collision could fully occur. Speed became heat, motion became pressure. A body from space, or something like it, became an event in the atmosphere. By the time the force reached the trees, the object itself may already have fragmented, vaporized, or dispersed beyond easy recovery. The Earth was still struck, but not in the ordinary way of a solid mass carving a bowl into soil and rock. It was struck through its air. This idea is calm when stated slowly, but it is unsettling when imagined fully. The air around living beings, the same air that carries breath and sound, can become a channel of destruction if enough energy is released suddenly inside it. The Tunguska forest shows that a crater is not required for the ground to suffer. A wave can be enough. A pressure front can be enough. Heat and shock can be enough. And because these things pass on, they leave behind damage without leaving behind the thing itself. That is why certainty becomes difficult. The damaged forest says much, but not everything. The missing crater says much, but not everything. Witnesses say much, but not everything. Each clue narrows the world of possible explanations, yet none of them alone closes the final door. This is where honest storytelling matters. It would be easy to make the absence sound like proof of a strange secret. It would also be easy to make the strongest scientific explanation sound as if every detail had been recovered perfectly. Both moves would weaken the truth. The more careful view is stronger. Tunguska was a real, immense, sudden event. The lack of a normal crater is one of the reasons scientists have long considered an atmospheric explosion to be the most reasonable broad explanation. But the precise nature of the incoming body, the exact height of the main release, and the fine details of its final moments remain subjects where caution is better than drama. A forest can guide us without giving us possession of the whole sky. This is the lesson at the end of the crater question. Absence is not the same as emptiness. A missing crater can be a form of evidence, because what is not present may rule out some simple pictures and point toward others, but absence must be read slowly. It cannot be stretched into any answer we desire. Human beings have always lived between what can be seen and what must be inferred. Our ancestors survived by noticing signs, but they also lived with causes they could not fully grasp. Tunguska returns us to that human condition in a modern form. Something crossed into the atmosphere. Something released force over the turmoil. Something flattened the forest without leaving the familiar wound people expected. The missing crater does not end the mystery. It gives the mystery its shape. The The strongest explanation for Tunguska begins with a simple idea that is difficult to picture calmly. A body from space entered Earth's atmosphere, moved at tremendous speed, and released most of its energy before it reached the ground. This kind of event is often called an airburst, but the word can sound too small for what it means. It does not describe a harmless flash. It describes speed becoming heat, pressure, shock, and light inside the atmosphere itself. The object does not need to land as a single large stone to change the surface below. It can break apart, slow violently, and turn its motion into a wave strong enough to flatten a forest. For Tunguska, this broad explanation fits many of the central clues better than a simple ground impact. It helps explain why witnesses saw brightness and felt heat. It helps explain why sound and pressure travelled across long distances. It helps explain why trees were pushed down over a wide region. It also helps explain why no ordinary crater was found at the centre of the damage. The most destructive moment may have happened above the ground, in air that later left no body behind. Still, even this strong explanation must be handled with care. To say that an atmospheric explosion is the best supported broad picture is not the same as knowing every hidden detail. The exact size of the incoming object is not something one can state with perfect certainty. Its composition remains discussed. Its path, breakup, and height of energy release have been reconstructed through models and traces, not watched directly with modern instruments. Tunguska gives enough evidence to guide science, but not enough to make every number sacred. That is why the event is both less mysterious and more humbling than a dramatic legend would make it. It is less mysterious because the airburst explanation has strong physical reasons behind it. It is more humbling because the details still depend on reading a vanished moment from damaged trees, scattered witness accounts, and absence where a crater might have been. To understand why an airburst could be so destructive, it helps to think about motion. A small object moving slowly can be harmless. A small object moving extremely fast can carry enormous energy. When such a body enters the atmosphere, it does not pass through emptiness. It collides with air molecules in front of it. The air cannot move aside gently enough. Pressure builds, heat rises. The object may weaken, crack, fragment, or explode as its own structure fails under stress. What reaches the ground is not necessarily a single object. It may be a blast wave, radiant heat, and scattered material too small or too altered to announce itself clearly. This is important because the human imagination often expects destruction to come from large visible things. A mountain falls. A boulder strikes. A wall collapses. But Tunguska shows a different kind of violence. A body that may have been modest compared with mountains, yet fast enough to release energy across the sky. Human beings evolved to judge danger at the scale of animal bodies. Falling branches, fire, cold, flood, and hunger. Our senses are not naturally prepared for cosmic speed. We can see a flash, hear a sound, feel pressure, and watch trees fall. But the process that turns an object's motion into atmospheric destruction is far beyond ordinary bodily experience. In the deep past, if early humans had witnessed a smaller version of such an event, they could have remembered the light, the noise, the fear, perhaps even the scorched ground. But they could not have known the physics of entry, fragmentation, or shock waves. Tunguska happened late enough for science to build that framework, after the fact. Yet it still began as the older experience. The sky acted, bodies reacted, and only later did explanation approach. The airburst hypothesis also respects the forest's testimony. It does not ignore the missing crater. It makes sense of it. It does not dismiss witness accounts. It places their light, heat, and sound inside a physical process. It does not turn the damaged trees into decoration. It treats them as the main map of pressure reaching the surface. This is why the explanation has endured. It joins separate clues without forcing them into a fantasy. But a good explanation does not need to pretend that uncertainty has vanished. The difference between a rocky asteroid and a more fragile icy body matters. The height of breakup matters. The angle of entry matters. The distribution of energy matters. Each one can change how the forest was damaged and why little obvious material remained. The surviving evidence can support a strong general picture while still leaving room for careful disagreement about finer details. That is not weakness. It is how responsible knowledge works when the main event was not directly measured. Tunguska teaches that probably can be a strong word when it is supported by many converging signs. It also teaches that probably should not be inflated into we know everything. The most honest version of the story stands between denial and exaggeration. Something from above likely released immense energy in the atmosphere. The forest below became the record of that release. The lack of a crater became part of the evidence rather than a failure of evidence. And the human mind, arriving late, had to learn how to see the sky not only as emptiness, but as a place where destruction could unfold before it ever touched the ground. To imagine an airburst clearly, it helps to slow the event down in the mind, even though the real thing would have moved too quickly for any witness to follow. A small cosmic body enters the upper atmosphere. At first it is simply travelling through space, where there is almost nothing to resist it. Then it meets air. At ordinary human speeds, air feels soft. A hand can move through it, a bird can ride it, a person can breathe it in sleep, without thinking of it as matter. But at cosmic speed, air becomes a barrier. The object compresses the air in front of it faster than that air can escape. Heat rises around the body, pressure increases. The outer surface begins to fail. If the object is not strong enough to survive the stress, it fragments. Fragmentation increases the surface area exposed to the air, which makes the energy release even more sudden. In a few moments, motion that once belonged to a body from space can become light, heat, sound, and shock moving through the atmosphere. This is the quiet mechanism behind the airburst idea. It does not require the object to dig a crater. It requires the object to surrender its energy overhead. The Tunguska forest below would then receive the event not as a single stone striking soil, but as a pressure wave spreading downward and outward. That is why the explanation speaks so directly to the pattern of damage. Trees do not need to be crushed by falling rock if the air around them is pushed with enough force. Trunks can snap, roots can fail, branches can be stripped. Fire can appear in some places without the entire event behaving like an ordinary forest fire. The event becomes both aerial and earthly. It begins above, but its record lies below. This is also why the witness accounts and the forest pattern belong together. People remembered light because energy was released in the sky. They remembered heat because the release was not merely mechanical, but thermal as well. They remembered sound and shaking because a shock travelled through air and ground. The forest remembered direction because pressure moved across it. No single kind of evidence carries the whole explanation, but each one fits more naturally within the airburst picture than within a simple ground impact. Still, the word fit should be used carefully. It does not mean every account is exact, every tree points perfectly, or every detail is finished. Nature is not a clean diagram. A blast wave moves through uneven terrain. Trees differ in strength. The ground varies in wetness and depth. Later decay changes the scene. Witnesses stand at different distances. Memory preserves experience more readily than geometry. The airburst explanation is strong because it gathers many imperfect clues into a coherent physical story, not because it turns the event into something perfectly known. That distinction is important for honesty. In many popular mysteries, uncertainty is treated as a doorway to anything. But in science, uncertainty is usually narrower. It means there are still ranges, not unlimited possibilities. The incoming body may have been a stony asteroid, or perhaps a more fragile object with different composition. The estimated size, speed, angle, and burst height can vary among studies. But these open details exist inside a broad frame supported by the damage itself. The forest was flattened by force. A crater was missing. Witnesses saw and felt an atmospheric event. The strongest explanation must respect all of those at once. Human beings have always tried to build such frames from incomplete signs. An early group finding a broken branch, scattered hoofprints, and disturbed mud might infer that an animal passed nearby even without seeing the animal. They would not know every detail of its movement, but they could know enough to act. Much of human intelligence grew from that balance between partial evidence and useful understanding. Tunguska asks for a modern version of the same skill. We do not need to invent a complete certainty where evidence does not allow it. We also do not need to surrender to confusion when evidence points strongly in one direction. The airburst hypothesis is a way of reading the forest, the sky, and the missing crater together. It is not a dramatic answer imposed from outside. It grows from the shape of the event itself. The most humbling part is that the main violence may have happened in a place no one could later visit. A crater can be walked around, a fragment can be held, but the actual zone where speed became heat and pressure existed only for moments in the air. Then it was gone. What remained was the shadow of that transformation on the land. A whole forest became the afterimage of a process that had already vanished. This is why Tunguska feels so close to the deep human condition even while belonging to modern science. Our species lives by reading afterimages. We infer ancient migrations from bones and tools. We infer old climates from pollen and ice. We infer vanished lives from marks in sediment. Here, we infer a vanished explosion from wood, memory, and absence. The sky did not leave a complete sentence. It left clauses scattered across Siberia. The airburst explanation is the careful attempt to read those clauses in the order that best preserves their meaning. The airburst explanation gives Tunguska its strongest frame, but it does not make the event small. It makes it more precise. A thing does not need to strike the ground in a visible, dramatic way to change a landscape. It can arrive from space, enter the atmosphere, break apart under forces beyond ordinary experience, and turn its movement into a blast that the ground receives as pressure, heat, and sound. In that sense, the Tunguska event teaches a difficult lesson about scale. Human beings are used to judging danger by size. A large animal is more dangerous than a small one. A large stone is more threatening than a pebble. A large fire is more dangerous than a spark. But cosmic speed changes that ordinary intuition. An object not especially large when compared with mountains, forests, or cities can carry energy far beyond what its size suggests because it is moving so fast. When that motion is stopped or broken apart suddenly, the release can be immense. The forest below does not care whether the cause looked large to the human eye. It only receives the energy. This helps explain why Tunguska can feel almost disproportionate. A remote sky event, lasting only moments, left a mark that required years of human effort to understand. The body that caused it, if the broad airburst explanation is correct, did not need to remain as a monument. Its most important property was not its final shape on the ground, but the energy it carried into the atmosphere. This is where the event becomes more than a physical mystery. It becomes a reminder of how limited human perception can be. Our senses evolved in a world of nearby dangers: teeth, cold falling branches, deep water, hunger, disease, fire, and other human beings. We are not naturally built to feel the hidden energy of an object crossing space before it reaches us. We notice the last expressions of that energy: light, heat, shock, broken trees. The cause itself may be almost over by the time the body understands danger. Early humans lived beneath the same sky with no way to distinguish many celestial events from weather, fire, or sacred fear. A sudden brightness could be remembered, but not calculated. A distant explosion could be feared, but not modelled. Even in 1908, with modern science already alive in the world, Tunguska first arrived in that ancient order. Sensation before explanation, survival before measurement, memory before theory. The airburst hypothesis is powerful because it brings those scattered sensations into a physical relationship. It says the light, the heat, the pressure, the sound, the flattened trees, and the missing crater are not separate puzzles. They may be different faces of one event unfolding above the ground. Yet the explanation must remain disciplined. The word airburst should not be treated as a magic word that erases uncertainty. It gives a broad mechanism, not a perfect reconstruction. Scientists can compare models, estimate ranges, and test whether different assumptions fit the damage better or worse. But they cannot return to the exact sky of that morning with modern instruments. They cannot place sensors inside the vanished blast. They cannot ask the incoming object to remain whole long enough for examination. The event has to be understood backward. This is why a careful story must keep two truths together. First, the broad scientific explanation is not empty speculation. It rests on the pattern of the forest, the witness memories, the lack of a normal crater, and what is known about high-speed objects entering Earth's atmosphere. Second, the fine details are not all equally certain. The object's exact composition, Its precise size, the height of its main energy release, and the way it fragmented are reconstructed, not directly observed. Holding both truths at once is not weakness. It is intellectual honesty. In the long history of our species, this may be one of the most valuable habits we have learned. To say what is likely, without pretending that likely means complete. Tunguska becomes calmer when seen this way, but not less profound. The mystery does not need to be inflated. The real world is already enough. A body from space probably entered the atmosphere above Siberia. It probably released enormous energy before reaching the ground. The air probably carried that energy into the forest as destructive pressure. But the event left no simple object at the center, no ordinary crater, and no complete immediate record. What remains is a strong explanation with open edges. Those open edges are not a failure of science. They are the shape of evidence after time, distance, and atmosphere have done their work. The sky acted quickly. The forest answered in broken wood. Human beings arrived later and began, slowly, to understand what kind of violence can pass through air and still leave the earth changed. Once the airburst picture is in place, a quieter question remains. What kind of body entered the atmosphere that morning? This question matters because not all objects from space behave in the same way. Some are dense and rocky, some contain more metal, some are more fragile, with more volatile material, dust or ice. Their structure changes how they respond to the atmosphere. A stronger body may travel deeper before breaking apart. A weaker body may fragment higher, spreading its energy over a broader area. A body that survives in pieces may leave material behind more clearly. A body that breaks apart and disperses may leave little that can be recognized easily in a living forest years later. Tunguska stands in the difficult space between these possibilities. The forest shows that energy reached the ground with great force. The missing, ordinary crater suggests the main release happened above the surface. Witnesses remembered light, heat, sound, and shock. But those clues do not point to one composition with perfect certainty. They narrow the question. They do not close it. This is why careful discussions often speak of a small asteroid or a comet-like body while admitting uncertainty in the details. The difference is not just a matter of names. A rocky asteroid suggests a body with enough strength to penetrate deeply into the atmosphere before disruption. A comet-like or more fragile object suggests something that might break apart more easily and leave fewer durable fragments. Each possibility can help explain some features, depending on the assumed size, speed, angle, and height of breakup. But each also has difficulties. If the object was rocky, why was no large, obvious fragment recovered? If it was fragile or icy, could it still produce the pattern and intensity of damage observed below? These are not questions to answer with drama. They are questions to hold with patience, because the event itself did not leave a simple sample on the ground. Human beings often want identity to be solid. We like to say, it was this, not that. A named object gives rest to the mind, but the natural world often leaves categories blurred. In the atmosphere, a body is not only what it is made of, it is also how fast it travels, what angle it enters, how it breaks, how energy spreads, how the air responds, and what survives afterward. Composition is important, but composition alone is not the whole event. A strong object entering at one angle may behave differently from a similar object entering at another. A fragile object may still release great energy if it carries enough speed. A small difference in altitude can change how pressure reaches the ground. Tunguska cannot be understood by naming the body and then stopping. The body must be placed inside a process. This is a useful lesson for thinking about human origins as well. The earliest people did not encounter nature as a set of clean labels. They encountered mixed processes: climate, animals, plants, fire, terrain, illness, hunger, and memory all acting together. A drought was not only lack of rain, it was fewer plants, weaker animals, longer travel, greater risk, changes in birth and death, and pressure on social groups. A volcanic eruption was not only a mountain releasing ash, it was darkness, cold, damaged water, altered movement, and stories carried forward. In the same way, Tunguska is not only asteroid or comet, it is object plus atmosphere plus forest plus time. The question of composition matters, but it lives inside the larger question of how energy became damage. If we imagine a rocky body, we might picture something more solid, more resistant, perhaps able to descend lower before failing. Such a body could release energy close enough to the surface to flatten trees strongly without digging a crater if it broke apart at the right height. If we imagine a more fragile, comet-like body, we might picture something that disintegrated more thoroughly, leaving less obvious material, perhaps helping explain why the ground did not yield a large surviving mass. But these images are simplified. Real objects can be mixtures. They can have cracks, uneven density, pockets of different material, and histories of collision before they ever meet Earth. Even the term comet-like can mislead if it makes the listener imagine a clean snowball. Natural bodies are often irregular, dark, dusty, fractured, and complex. Tunguska asks us to avoid turning scientific categories into bedtime certainty. The most honest approach is to say that the event was most likely caused by a small natural body from space releasing energy in the atmosphere, while the exact nature of that body remains less certain than the broad mechanism. That statement may sound less dramatic than a final label, but it is stronger because it matches the evidence more carefully. The forest did not preserve a passport for the visitor from the sky. It preserved the force of its arrival. From that force, science can build a serial explanation, but not an unlimited one. In the quiet center of this question, there is a humbling truth. Sometimes the Earth remembers what happened better than it remembers who did it. Tunguska's trees remembered pressure. Witnesses remembered light. The ground remembered no simple crater. The body itself may have been transformed beyond recognition in the very act that made it unforgettable. A rocky asteroid and a more fragile comet-like body both belong to the same larger family of natural visitors from space, but they carry different habits into the atmosphere. A denser, rocky object may hold together longer as it descends. It can push deeper before the forces around it become greater than the strength within it. If it finally breaks apart at lower altitude, the energy can be delivered closer to the ground, and the pressure wave below can be intense. A more fragile body, especially one with more volatile material or a looser structure, may fail higher in the atmosphere. It may spread its energy over a different shape of sky, perhaps leaving less obvious material behind. This difference helps explain why the identity of the Tunguska body has remained so carefully discussed. The question is not simply which label sounds better. The question is which kind of body, entering at which speed, at which angle, and breaking at which height, best matches a forest pressed outward by force, witnesses who remembered light and heat, and a ground that did not offer a simple crater. The difficulty is that several variables can compensate for one another. A smaller, stronger body breaking lower might produce some effects that resemble a larger, weaker body breaking higher. A steep entry may concentrate energy differently from a shallow one. A body with internal cracks may fail sooner than its general composition would suggest. Even a rocky object is not always a perfect stone. It can be fractured, irregular, or mixed. Even a comet-like object is not a clean ball of ice. It may contain dust, darker material, and uneven structure. The real sky is less tidy than the categories used to describe it. This is why a careful story should not turn asteroid or comet into a simple contest with one dramatic winner. The event did not leave enough direct material to make that kind of confidence easy. It left effects, and effects must be interpreted through models, comparison, and restraint. The forest gives the broad shape of the energy. The missing crater gives a strong clue about where the main release likely occurred. Witnesses give the human experience of the sky becoming bright, hot, loud, and violent. But none of these clues alone can show the object's interior. They do not tell us how many cracks it had, how dense it was, how much of it vaporized, or how much material may have fallen in particles too small or too scattered to settle the question. In this sense, Tunguska again resembles the deeper human past. When archaeologists find a stone tool, they may know the material, the edge, and the marks of use, yet they do not know every thought of the person who held it. When they find a hearth, they may know fire was present, but not every voice around it. The surviving trace is real, but it is not the whole life of the event. Tunguska's trace is larger, stranger, and more violent, yet the principle is the same. We know through what remains, and what remains is never the full moment itself. A rocky asteroid explanation has a certain strength because stony bodies are common among near-Earth objects and can carry energy deep into the atmosphere. Such a body, if it broke apart above the surface, could flatten trees without leaving a classic crater. It could release enough energy close to the ground to make the forest record so severe. But the absence of large recovered fragments keeps the matter open at the edges. A more fragile or comet-like body has its own appeal because a body that disintegrates thoroughly could help explain the lack of obvious surviving material. Yet, fragility also raises questions about whether it could survive deep enough to produce the observed force at the surface, unless its size, speed, angle, and breakup conditions were right. Both paths require more than a name. They require a physical story. That is the central point. The Tunguska object cannot be understood apart from its final seconds in the atmosphere. Its identity was expressed not only in what it was made of, but in how it failed. Failure, in this case, is not a small detail. It is the event. The body's breaking, heating, fragmenting, and energy release are what turned an object from space into a pressure wave in a Siberian forest. For human beings, this is a hard kind of evidence because it concerns transformation rather than survival. We can study a bone because it remains bone. We can study a tool because it remains stone. But the Tunguska body may have become light, heat, shock, dust, vapor, and scattered traces in the same act that made the event visible. Its disappearance was not separate from its power. Its disappearance was part of how that power reached the ground. That idea brings the mystery closer to truth and farther from fantasy. The question is not whether anything imaginable could have happened. The question is which natural process best matches the evidence without demanding more than the evidence can give. A rocky asteroid, a more fragile object, or something with mixed properties all belong inside that disciplined space. What stands outside it are explanations that ignore the forest, ignore the witnesses, ignore the missing crater, or treat uncertainty as a blank page. Tunguska deserves better than that. It asks for a slower mind, one willing to accept that the strongest answer may still have soft edges. The object may never be known with the intimacy of a stone held in the hand, but its final effect is written across the taiga. The forest does not tell us its name completely. It tells us how violently it arrived, how quickly it changed, and how much of a visitor from the sky can vanish while still leaving the earth altered. The question of what the Tunguska body was may never be answered in the satisfying way people often want. There may never be a single recovered stone large enough to end the discussion. No unmistakable object with a surface, weight, and interior that can be placed before the mind as the final witness. Instead, the body must be understood through what it did while it was disappearing. That is a difficult kind of knowledge, but it is not weak knowledge. Many real events are known through transformation. A flame is understood partly by the ash it leaves, a flood by the mud line on a wall, a vanished animal by tracks pressed into soft ground. The cause is gone, but the effect remains arranged enough to be read. Tunguska belongs to that family of evidence. The visitor from the sky, whether more rocky, more fragile, or mixed in structure, became known to us mostly through its failure in the atmosphere. Its identity was written not as a preserved object, but as a pattern of light, pressure, heat, sound, and fallen wood. This is why the argument over asteroid or comet should remain quiet and disciplined. It is not a place for certainty beyond evidence. It is a place for comparing how different natural bodies would behave when entering air at extreme speed. A rocky body might descend more deeply before breaking, releasing energy close enough to the surface to damage the forest strongly. A more fragile body might break apart more completely, leaving less obvious material behind. A mixed or fractured object might behave in ways that blur the line between the two simple labels. Each possibility is not judged by how dramatic it sounds, but by how well it fits the same stubborn facts: the sudden blast, the wide forest damage, the witness reports, and the absence of a normal impact crater. The event becomes clearer when we stop asking for the object's name alone and begin asking how matter, speed, air, and height work together. In that sense, Tunguska is less like identifying a lost tool and more like reconstructing a breath after it has passed through a cold room. The air moved. The surface changed. The original motion vanished. What remains is a trace of process. Human history is full of such traces. Our earliest ancestors left us no diaries explaining why they crossed a valley or chose one shelter over another. We infer from stone, bone, ash, footprints, and the slow arrangement of objects in soil. We know that they lived through real dangers, but the full event often lies beyond recovery. The Tunguska body is similar in principle, though very different in scale. It passed through the sky, changed form, released energy, and left behind a landscape that could be read but not completely interrogated. This does not make all answers equal. The broad airburst explanation remains strong because it gathers the main clues into one physical story. The uncertainty lies inside the details, not outside the evidence. That distinction protects the listener from two errors. The first error is to pretend that because some details are uncertain, no serious explanation exists. The second is to pretend that because one explanation is strongest, every detail has been proven beyond question. Tunguska lives between those errors. It gives enough evidence for a responsible explanation and enough missing evidence to keep the explanation humble. The question of asteroid or comet also reminds us that natural categories are human tools, not walls built into the sky. A body from space may be fractured, dusty, icy, stony, metallic in parts, or altered by collisions long before it ever meets Earth. It may not match the clean image that a single word suggests. When it enters the atmosphere, its past and its structure matter, but so does the violent present of entry. Strength, density, speed, angle, rotation, internal cracks, and atmospheric pressure all become part of its final behavior. The forest below receives only the result. It does not receive a label. This is a calm but important lesson for the whole story. The title asks what flattened the trees, but the most careful answer may not be a simple noun. It may be a process, a natural body entering Earth's atmosphere, breaking apart, releasing energy above the ground, and sending a pressure wave across the taiga. Within that process, the exact nature of the body remains less certain than the event it produced. For a listener near sleep, there is something deeply human in accepting this. We live in a world where many causes do not remain for us to hold. We learn by traces, by comparisons, by patterns that survive after the living moment is gone. Tunguska teaches that uncertainty does not have to become confusion. It can become a boundary around honesty. The forest was flattened, the sky was involved, the air carried force. The object did not leave a simple crater or an easy sample, and somewhere inside that loss of form, the body from space gave up its identity almost at the same moment it gave the Earth its mark. One of the most dangerous misunderstandings around Tunguska is hidden inside the phrase, "nobody knows." The phrase is useful only if it is handled carefully. It can mean that no one knows every detail with perfect certainty. It can mean that the exact body, its interior, its angle, its breakup, and its final moments remain partly reconstructed rather than directly observed. But it should not mean that every explanation is equally reasonable. A gap in knowledge is not an open field where any story may enter. It is a boundary. It tells us where evidence grows thinner, not where evidence disappears entirely. Tunguska gives us many firm signs. A sudden event occurred over central Siberia. Witnesses described light, heat, sound, and shock. A wide forest was flattened in a pattern that pointed toward a powerful central release of force. No ordinary crater was found to match a simple ground impact. Later studies showed that the event could be understood most coherently as a natural body releasing energy in the atmosphere. These signs do not settle every fine detail, but they do not leave the mind with nothing. They narrow the world of possible answers. That narrowing is the quiet strength of science. It does not need to shout. It simply asks which explanations can carry the evidence without breaking under it. Some ideas fit the evidence better because they explain several clues at once. A high-speed natural object breaking apart in the atmosphere can help explain the light, the pressure wave, the damaged forest, and the missing crater in one connected process. Other ideas may sound more dramatic, but if they ignore the forest pattern, require evidence that was never found, or depend on special assumptions that do not arise from the site itself, they become weaker. The difference is not about imagination. Human imagination is powerful, and it has always helped us face the unknown, but imagination is not the same as explanation. In the deep past, when early humans met strange lights in the sky, sudden fires, floods, or trembling ground, they did not have instruments to separate one cause from another. They had memory, fear, pattern, and story. Those stories could preserve warnings, but they could also join events in ways that later science would separate. Tunguska stands at the edge between that ancient habit and modern discipline. It invites wonder, but it also asks wonder to be patient. The strongest explanation is not the one that feels most exciting. It is the one that leaves the fewest clues abandoned. This matters because mystery can be misused. If a person says that because Tunguska was not fully observed, it could have been anything, they have stepped away from the evidence. The forest is not anything. The witness memories are not anything. The missing crater is not anything. They are specific signs, each with limits, each pushing the mind in certain directions and away from others. A careful answer must listen to those directions. It must also admit where the directions fade. That balance can feel unsatisfying if the mind wants a clean ending, but it is more faithful to the real event. Human beings did not become wise by pretending uncertainty was certainty. We became wiser by learning how to live with different strengths of knowledge. Some things are directly observed, some are strongly inferred, some are plausible but unproven, some are merely imagined. Tunguska asks us to keep those levels separate. It is likely not a mystery in the sense of having no natural explanation. It is a mystery in the more honest sense, a real event with a strong explanation, and with details that remain beyond full recovery. That kind of mystery is quieter, but deeper. It teaches that truth is not always a closed door. Sometimes it is a path through a forest, where each fallen tree points part of the way, and none of them points alone. The easiest way to misunderstand Tunguska is to treat uncertainty as a doorway instead of a fence. A doorway invites anything to walk through. A fence marks where the evidence stops and where imagination must not pretend to be evidence. Tunguska has fences. They are not perfect walls, but they are real. The forest was flattened in a pattern that speaks of force moving from a central region. Witnesses remembered light, heat, pressure, and sound. The ground did not offer a simple crater where a large solid body had struck and remained. The event happened in a remote place. An investigation came late, which means some details were lost or softened by time. These facts do not create a blank page. They create a shape. Inside that shape, some explanations become strong, some remain possible only in narrow ways, and some fall away because they do not respect the evidence. This is one of the quiet differences between mystery and confusion. A mystery still has edges. Confusion has none. Tunguska is a mystery with edges. It is not a story where every strange idea deserves equal space. A natural airburst caused by a small body from space fits the main signs because it explains why the sky was bright, why the air struck like force, why trees fell outward, and why the land did not preserve an ordinary crater. That explanation does not solve every measurement, but it carries more of the evidence than dramatic alternatives that depend mainly on surprise. A careful mind should notice this. The strongest explanation is not always the most emotionally satisfying. It may be less colourful, less cinematic, and less easy to sell as a secret. But it has a deeper strength because it stays close to what the world actually left behind. This matters far beyond Tunguska. Human beings have always lived with incomplete knowledge. In the earliest parts of our story, a group might see smoke beyond a ridge and not know whether it came from lightning, another group, volcanic ground, or a spreading fire. They might find bones broken open and not know whether people, animals, or natural forces had done the work. They might see a bright object cross the night sky and remember it for years without knowing what had burned above them. In such conditions, imagination was not useless. It helped people prepare, warn, and remember. But imagination also had to live beside observation. A person who ignored tracks, wind, season, and smell could be led into danger by a beautiful story. The same is true in modern form. When we speak of Tunguska, the unknown parts should make us more attentive, not more careless. They should make us ask which claims are supported by the forest, which are supported by witness accounts, which are supported by known physics, and which are only filling silence with drama. There is dignity in saying no to a tempting explanation when it does not carry enough evidence. There is also dignity in accepting a strong explanation without forcing it to become absolute. The event most likely involved a natural body entering the atmosphere and releasing energy above the ground. That broad statement is supported by the pattern of the damage. But the exact nature of the body, whether more rocky, more fragile, or mixed, remains less certain. The height and details of breakup are reconstructed, not directly recorded by modern instruments at the scene. These limits do not weaken the honest answer. They protect it. They keep it from becoming the kind of certainty that later breaks under scrutiny. In science, a good explanation is not a story that never admits a missing piece. It is a story that shows where the pieces are missing and still explains why the remaining pieces fit together better one way than another. Tunguska gives us enough to reject ordinary forest fire, ordinary storm damage, and simple ground impact as complete explanations. It gives us enough to take the airburst idea seriously. It does not give enough to claim every fine detail as if someone had watched the event with perfect instruments from every angle. That is the balance. It is calm, but it is not weak. It is careful, but it is not empty. For a listener moving slowly towards sleep, there is something valuable in this kind of thinking. The world is full of things we partly know. The history of life, the migration of early humans, the disappearance of ancient communities, the memories held in bones and tools, all of these are known through traces, probabilities, comparisons, and humility. Tunguska belongs to that same family of knowledge. It teaches that the unknown should not be used as a place to hide anything we wish to believe. It should be treated like the dark edge of a forest at night, approached with attention, entered only where the ground can be felt, and respected where the path disappears. The careful way to speak about Tunguska is to give the known facts their full weight, and the unknown details their proper silence. That is not always easy. A story with a missing crater and a vanished object naturally draws the imagination toward extremes. One mind may want to close the question too quickly, as if the strongest explanation must have every detail already fixed. Another mind may want to open the question too widely, as if the absence of perfect knowledge removes all boundaries. Both impulses are understandable, but neither serves the truth well. Tunguska asks for a slower discipline. The forest was flattened. The witnesses remembered light, heat, sound, and shock. The damage had a broad pattern. The region was remote. Scientific investigation came late. No ordinary crater stood at the center to make the event simple. These facts are enough to guide understanding, but not enough to turn every hidden second into a settled picture. A good explanation must live inside that balance. It must be strong enough to connect the evidence, and modest enough to admit where the evidence fades. The airburst idea does this better than the alternatives, because it allows the main violence to happen above the ground. It explains how the sky could become bright, how the atmosphere could carry pressure, how trees could fall across a wide area, and why the ground might not show a classic impact scar. But even a strong explanation does not become a license for careless detail. The exact body may not be known in the way a recovered stone would be known. Its structure, composition, angle, and breakup are reconstructed from aftermath, not observed directly at the moment of failure. To say that clearly is not to weaken the story. It is to protect it from becoming false certainty. Human beings have always needed this kind of protection. We are a storytelling species. And storytelling is one of our oldest tools. It helped early people remember dangerous places, pass on warnings, keep group memory alive, and give shape to experiences that were too large or frightening to hold alone. A story can save life if it preserves a real pattern. But a story can also mislead if it becomes more important than the marks on the ground. The earliest humans lived by watching traces, animal paths, broken branches, ash, weather, tracks, and the behavior of other living things. Their minds joined signs into meaning. Modern science is not a rejection of that ancient habit. It is a refinement of it. It asks the same basic question with stricter patience. What do the traces actually allow us to say? Tunguska is a clear example of that refined patience. The fallen trees allow us to say that force moved through the forest with immense power. The witness accounts allow us to say that the event entered human experience as light, heat, sound, and shock. The missing crater allows us to question a simple ground impact. The delay before investigation allows us to understand why some evidence was lost or softened. But none of these signs allows us to invent without limit. None of them allows every dramatic claim to stand beside the strongest scientific explanation as an equal. Evidence is not a decoration placed around a mystery. It is the thing that gives the mystery its honest shape. That shape is narrower than fantasy, but wider than certainty. It is a place where careful words matter. Likely is not the same as guessed. Uncertain is not the same as unknown in every way. Not fully solved is not the same as open to anything. These distinctions may seem quiet, but they are the difference between knowledge and confusion. In a world filled with striking claims, Tunguska teaches a calm form of resistance. It teaches that an unanswered detail should not be treated as a hole to fill with whatever captures attention. It should be treated as a marked edge, a place where the honest mind stops, looks around, and says only what can be supported. That habit has value beyond one Siberian forest. It matters when we think about ancient migrations, extinct human relatives, lost settlements, old climates, and the fragile beginnings of our own species. Much of the human past is known through partial remains. A bone does not tell a whole life. A tool does not tell a whole mind. A footprint does not tell the full journey. Yet together, traces can tell us something real. They can guide us without giving us possession of everything. Tunguska belongs to that same lesson. It is not a blank mystery. It is not a finished sentence either. It is a field of evidence with a strong direction and open edges. The most truthful way to leave it is not with a dramatic secret, but with respect for the limits that make knowledge honest. Something happened above the taiga. Something turned speed into pressure. Something made the air strike the forest like a physical wall. The best explanation points toward a natural airburst, but the final details remain partly beyond recovery. That is not failure. It is what reality often looks like after the sky has acted faster than human history can record. Tunguska becomes larger when it is placed beside the long history of human vulnerability. At first, it may seem like a rare event in a remote forest, a violent morning in Siberia that belongs mostly to astronomy, geology, and damaged trees. But beneath that physical story is another story, older and quieter. Human beings have always lived under a sky they could not fully control. For most of our time on Earth, we could not measure objects approaching from space. We could not calculate orbits, compare atmospheric models, or build networks of observation across continents. We could look upward. We could notice light, weather, darkness, stars, seasons, and strange movements. We could remember. We could speak. But the sky remained beyond the reach of ordinary human power. Tunguska reminds us of that older condition because, even in the 20th century, the event first reached people not as data, but as fear, heat, sound, and broken forest. The modern world existed, but it was not present in the right place at the right second. This is close to the way nearly all earlier humans met sudden natural danger. The body received the event first. Explanation came later, if it came at all. A group living tens of thousands of years ago might have seen a bright object split the night, heard distant thunder without storm clouds, or found a patch of burned ground where nothing familiar had happened. They would have interpreted it through the knowledge available to them, memory of weather, fire, animals, ancestors, and place. They could not have known orbital mechanics or atmospheric entry, yet their experience would still have been real. Their fear would still have been reasonable. Their attempt to turn the event into memory would still have been part of survival. Tunguska sits in the modern record like a reminder that our intelligence did not begin with certainty. It began with attention. Before humans could explain the sky, they had to live beneath it. This matters because the Tunguska event did not kill a civilization, erase a city, or become a global turning point in political history. Its largest human lesson is quieter than that. It shows that the planet's surface can be changed suddenly by forces that are not part of daily life, and that human history is partly shaped by where such forces happen to arrive. If the burst had occurred over a dense city, it would be remembered differently. It might have become one of the defining disasters of modern history. Instead, it arrived over taiga, where the forest took the blow and the human record remained thin. That fact is not only geographic, it is moral in a gentle sense. It reminds us that many human lives have depended on chance locations, where a flood broke, where a drought deepened, where disease travelled, where a volcano darkened the air, where animals moved, where ice opened or closed a path. Early human groups were never outside nature. They were embedded in it. Their bodies, movements, births, deaths, tools and stories were shaped by landscapes that could nourish them for years and then change without warning. Tunguska gives a modern image of that old truth. The trees fell in seconds, but the deeper message stretches backward through the whole human story. We are a species that learn to survive by noticing patterns, yet not every danger gives long warning. We are a species that learn to make tools, yet not every force can be held in the hand. We are a species that learn to tell stories, yet not every event can be made complete by language. The airburst explanation, strong as it is, also carries this lesson. It says that the most important violence may have happened in a place no one could reach afterward, a volume of atmosphere where speed, heat, pressure, and fragmentation existed for only moments. Human beings arrived after the transformation. They read the trees. They listened to witnesses. They studied the absence of a crater. That is what we often do with the past. We arrive after the living event and ask what remains. The same is true when we study the beginning of our species. We do not see the first memory, the first fear of the dark, the first careful watching of stars before sleep. We find bones, tools, pigments, hearths, footprints, and traces of movement. We reconstruct, cautiously, from remains. Tunguska is not a story about human origin in the narrow sense, but it touches the same foundation. The human mind grew in a world of incomplete evidence. Our ancestors did not need perfect certainty to live. They needed enough attention to respond, enough memory to pass warnings forward, and enough humility to know that the world was larger than their understanding. In that way, a flattened Siberian forest becomes more than a record of one natural event. It becomes a mirror held up to the human condition. We live with intelligence but not mastery. We live with science, but not total possession of every moment. We live beneath a sky that has become more measurable than it once was, yet still not small. Tunguska does not ask us to be afraid of the sky. It asks us to remember the scale of the world that shaped us. There is a quiet difference between danger that comes slowly and danger that arrives without asking to be understood. Human beings are good at learning slow danger. We can notice seasons changing. We can follow animal paths. We can remember which plants appear after rain, which rivers rise, which cold winds mean winter is near. Much of human survival was built from this patient noticing. But Tunguska belongs to another class of event. It was not a season, not a drought unfolding across months, not a disease moving through a group day by day. It was a sudden crossing between sky and earth. The event did not offer the forest time to adapt. It did not offer witnesses a sequence they could study while it happened. It arrived as light, pressure, sound, and force, and only afterward did the human mind begin to gather the pieces. This is why Tunguska speaks so directly to the fragility of human history. We often imagine history as something made by human decisions. Kings, cities, migrations, wars, tools, inventions, and beliefs. Those things matter, but beneath them is a deeper layer of natural condition. Bodies need water, warmth, food, shelter, and safety. Groups need land that can be crossed, animals that can be hunted or herded, plants that can be gathered or grown, and skies that do not suddenly become destructive. For most of our existence, humans did not stand above that layer. They lived inside it. A strange event in the sky could be remembered not as a scientific problem, but as a change in the meaning of a place. A valley might become feared. A clearing might be avoided. A story might be told to children, not because anyone knew the physics, but because the memory carried a warning. Tunguska, in a modern setting, lets us see that older relationship without having to invent it. The people who felt the blast did not first ask a technical question. They lived through a bodily event. The later question came only when the pressure had passed, and the forest remained broken. In that order, body first and explanation later, we can glimpse a pattern as old as humanity. The earliest humans were not weak because they lacked modern science. They were deeply attentive because they had to be. They knew that the world could not be controlled completely. They learned to live with uncertainty by sharpening observation, memory, and cooperation. A sound in the distance might mean weather, animals, enemies, or falling rock. A change in animal behavior might mean fire, storm, or danger unseen. A bright object in the sky might be beautiful, frightening, meaningless, or deadly depending on what followed. The mind had to sort signs quickly, but also carry them forward in story. That ancient habit still lives in us. When Tunguska is described, we still begin with images the body understands. Heat, light, shock, trees falling. Only then do we move toward atmosphere, energy, velocity, and models. Science expands the story, but it does not erase the bodily beginning. This is one reason the event remains powerful. It reminds us that knowledge did not begin as abstraction. It began as survival under conditions larger than the self. The flattened forest also shows how chance can shape what history remembers. A natural event does not choose its witnesses according to human importance. It does not ask whether a place has instruments, writing, roads, or dense population. It enters where physical paths carry it. If Tunguska had happened over a city, its memory would likely have been organized around human loss, architecture, emergency, and national response. Because it happened over taiga, the trees became the main sufferers and the main record. The event was not smaller because fewer people recorded it. It was only recorded differently. This distinction matters when thinking about human history as a whole. Many events that shaped early populations may have happened in places where no durable record survived. Floods, fires, cold periods, local extinctions, diseases, volcanic ash, and unusual sky events may have changed routes, diets, births, deaths, and memories without leaving clear human testimony. The absence of a written record does not mean absence of experience. It often means only that the experience belonged to people whose traces were fragile. Tunguska, with its broken forest and delayed investigation, helps us respect that fragility. It teaches that the past is not equal to what was easily recorded. The past includes what happened in remote places, to small groups, to forests, animals, and landscapes that did not speak in official language. This is part of the educational value of the story. It slows the mind down. It asks us not to confuse visibility with importance. The airburst over Siberia became famous because later science returned to it, but the basic condition it reveals is much older. Life on Earth is exposed to forces that do not always announce themselves in human terms. Our intelligence is real, and our science is powerful, but both often arrive after the first contact between nature and the body. Tunguska is a lesson in humility without despair. It shows that humans can investigate, compare, model, and learn, even when evidence is incomplete. It also shows that learning begins by admitting scale. The forest was larger than any single witness. The sky was larger than the forest. Time was larger than the investigation. And the human mind, moving slowly through all three, still found a way to ask better questions. The greatest vulnerability revealed by Tunguska is not that a rare object can enter the atmosphere. It is that human meaning usually arrives after nature has already acted. The forest did not wait for explanation before falling. The pressure wave did not slow down so witnesses could understand it. The sky did not leave a clear label behind. Everything happened first, and knowledge followed later, walking slowly through distance, memory, and broken wood. This order is familiar in the deeper story of our species. Human beings have always lived after the first act of nature. A storm arrives before a name is given to it. A fire spreads before anyone understands the wind. A river floods before a community can decide what the flood means. A strange light crosses the sky before anyone can separate beauty from danger. Tunguska is a modern example of that ancient order. It tells us that even with science, maps, and later investigation, the first encounter between life and sudden force is still bodily, immediate, and unfinished. The body feels before the mind explains. The forest breaks before the model is built. The witness remembers before the theory is formed. This is not a weakness unique to people of the past. It is a condition of being alive on a planet where many forces are larger and faster than us. What has changed over time is not the fact of vulnerability, but the way humans respond to it. Early humans could not predict objects from space, but they could watch patterns. They could learn from repeated danger. They could share memory. They could move camps, teach children, avoid certain places, and shape fear into caution. Later societies built records, calendars, instruments, observatories, and scientific methods. The movement from ancient attention to modern measurement is one of the quiet achievements of our species. Yet Tunguska shows that this achievement is not complete mastery. It is a better way of listening. Science did not prevent the event. Science did not arrive in the exact second of the blast. But science gave later generations a way to read the damage without surrendering to rumor or fantasy. It gave structure to uncertainty. It allowed people to say that some explanations fit the evidence better than others, while still admitting where the evidence thins. That is a deeply human kind of progress. It does not make us invulnerable. It makes us less blind. The fallen trees in this sense become more than wreckage. They become part of the long human education in scale. A single person's life is small beside a forest. A forest is small beside the atmosphere. The atmosphere is small beside the space through which natural bodies travel. And yet the human mind, fragile as it is, can move outward through inference. It can stand among fallen trunks and think about air. It can listen to a memory of heat and think about energy. It can notice the missing crater and think about what happened before the ground was reached. This ability did not appear suddenly in modern laboratories. It grew from the older habit of reading traces, a footprint, a tool edge, a layer of ash, a broken bone, a change in animal movement. Tunguska reminds us that the same mind which once learned from tracks in mud now learns from forests flattened by atmospheric force. The scale has changed, but the root habit remains. We are trace readers. We are late arrivals who try to understand what has already passed. That should make the story calmer, not smaller. The value of Tunguska is not only in asking what object entered the sky, it is in seeing how humans learn when certainty is incomplete. The event teaches that humility and knowledge are not opposites. A humble answer can be stronger than a dramatic one if it stays close to evidence. A careful explanation can be more useful than a shocking claim if it helps people understand the world without distorting it. This matters for anyone listening at night, when the mind naturally moves toward large questions. The history of humanity is not a simple rise from ignorance to control. It is a long, uneven movement from fear toward attention, from attention toward memory, from memory toward measurement, and from measurement toward a more honest sense of our place. Tunguska belongs to that movement. It shows a forest struck by force, a sky that did not explain itself, and human beings returning later to ask what could still be known. The answer is not everything, but it is enough to teach care. It is enough to remind us that the world does not become less real when we admit limits. It becomes more trustworthy, because we have stopped forcing it to speak beyond the evidence it leaves. In the end, Tunguska does not only show that humans are fragile beneath the sky, it shows that our deepest strength may be the patience to look at a broken landscape and learn without pretending to own the whole truth. By the time the story reaches its quiet end, the forest is no longer only a scene of destruction. It has become a place where several kinds of truth meet without fully merging. There is the physical truth of broken trunks, scorched bark, pressure, sound, and a wide pattern of force. There is the human truth of witnesses who felt the sky become dangerous before they could name what was happening. There is the historical truth of distance, delay, and a world not ready to measure the event as it occurred. And there is the scientific truth, careful and incomplete, pointing most strongly toward a natural body releasing energy in the atmosphere while still leaving some details beyond recovery. Tunguska becomes powerful because all of these truths stand together. None of them alone is the whole story. The forest cannot tell us every property of the object. The witnesses cannot measure every angle or height. The missing crater cannot speak by itself. The airburst explanation gathers the clues, but it does not turn the vanished morning into something perfectly possessed. What remains is not ignorance. It is knowledge with edges. That may be the most honest kind of knowledge humans often have. Much of our species' past has the same shape. We do not hold the first spoken words, the first fear of a falling star, or the first memory passed from one generation to another under a dark sky. We hold traces. We hold tools, bones, ash, footprints, pigments, pollen, and scars in the earth. From these, we build careful stories, not because we know everything, but because the fragments are not meaningless. Tunguska belongs to that wider human way of knowing. It reminds us that the world often leaves enough for understanding, but not enough for pride. The sky acted quickly. The forest answered in wood. People remembered what their bodies could carry. Science arrived later and listened to the remains. This order is deeply human. We arrive after the fact. We gather signs. We compare them. We learn to say likely, uncertain, possible, and unsupported without confusing one with another. In that discipline there is a kind of peace. It does not remove mystery, but it gives mystery a truthful shape. The fallen trees are not a doorway to any fantasy. They are a boundary around a real event. They tell us to look upward, but not wildly. They tell us to consider air, speed, pressure, and fragmentation, but not to pretend we witnessed every hidden second. They ask us to respect what evidence can do, and also what it cannot do. For a listener resting in the dark, this may be the quiet value of the Tunguska story. It is not only about destruction, it is about how the human mind meets something larger than itself and chooses patience over noise. A forest can be flattened in seconds. A question can remain for generations. Between those two timescales, human understanding slowly learns its proper size. We are small beneath the sky, but not helpless. We are late to many truths, but not unable to read them. We are surrounded by forces older than memory, yet we can still ask careful questions without turning uncertainty into fear. The Tunguska forest, silent now except in records, studies, and imagination, leaves us with that calm instruction. Look closely, speak carefully, and remember that the world is not less wondrous when we refuse to exaggerate it. Its lesson is not that nature hides secrets to defeat us. Its lesson is that reality is often larger than the first story we want to tell. The trees fell once, but the act of understanding them continues, softly, through every mind willing to separate evidence from desire and wonder from invention. In that slow separation, the mystery becomes less noisy and more worthy of being heard. Beneath sleep, it still keeps its shape. The quietest part of Tunguska is that the strongest answer does not remove the wonder. It changes the kind of wonder we are allowed to keep. At the beginning, the mind may be drawn to the missing crater, the sudden light, the vast forest pressed down, and the uncomfortable thought that something powerful arrived from above and left no simple object behind. These details feel like an invitation into darkness, but as the evidence is followed slowly, the darkness becomes less empty. The fallen trees point toward direction and force. The witness accounts preserve light, heat, sound, and shock. The absence of a normal impact scar turns attention away from a simple ground collision and toward an event in the atmosphere. The broad explanation of a natural airburst gathers these signs into a sober picture. Yet, even after that, the story does not become ordinary. It remains profound because it shows how reality can be both understandable and incomplete at the same time. That is a difficult balance for the human mind. We often want either total certainty or total mystery. Tunguska gives neither. It gives a strong path through evidence, and then leaves some details at the edge of recovery. The object's exact nature, the fine structure of its breakup, the precise moment when its energy became destructive pressure, these may remain partly beyond us. Not because the world is magical, but because the event was fast, remote, and only partly recorded. There is no shame in that. The shame would be to pretend the limits are not there, or to fill them too quickly with a story that feels more complete than the evidence allows. This is where Tunguska becomes educational in the deepest sense. It teaches not only a fact about the sky, but a habit of mind. It teaches that uncertainty should be approached with care, not fear. It teaches that a careful answer can still be beautiful. It teaches that the absence of one kind of evidence can become evidence of another kind, if it is read in relation to everything else. A missing crater is not simply a blank. It is a clue when placed beside the trees, the witnesses, and the physics of objects entering the atmosphere, but it remains only a clue. It must not be stretched until it breaks. Human beings have always needed this discipline. In the earliest parts of our story, Our ancestors lived by interpreting a world that rarely explained itself. A track in wet soil could mean food, danger, or both. Smoke beyond a ridge could mean lightning, fire, another group, or volcanic ground. A dead animal near water could mean disease, predator, poison, or chance. Survival depended on reading signs well, but also on knowing that signs could mislead if they were forced into the wrong story. Modern science grows from the same root, but with slower tools and stricter tests. It asks the ancient question in a more patient way. What does the trace truly support? Tunguska is a perfect example of that question. It is tempting because it is dramatic. It is valuable because it resists being made too dramatic. The real facts already carry enough weight. A remote Siberian forest stood beneath the morning sky. A natural force entered the atmosphere. Energy was released with extraordinary violence. Trees fell across a vast region. People felt the air itself become dangerous. Later investigators arrived and found not a simple crater, but a damage pattern that had to be read like a map. Nothing in that sequence needs exaggeration. The restraint makes it stronger. It lets the listener feel the event without being pushed into false certainty. It also places human beings in their proper scale. We are not outside nature, looking down on it from a safe distance. We are inside the same atmosphere, beneath the same sky, on the same moving planet. Our knowledge has grown immensely, but our knowledge is still a conversation with traces. We study what remains after the flash, after the pressure wave, after the forest begins to decay, after memory has begun to settle into words. That does not make knowledge weak. It makes it honest. A bone from an ancient human relative, a footprint hardened in old sediment, a burned hearth beneath layers of soil, a forest flattened by pressure from above. All of these ask the same calm response. Look closely, compare patiently, speak only as far as the evidence permits. Leave the rest open without turning it into spectacle. In that way, Tunguska becomes more than a question about what flattened the trees. It becomes a lesson in how to live with partial knowledge. The world is not obligated to give us complete answers in the shape we prefer. Sometimes it gives us a pattern, a scar, a memory, an absence, and asks whether we can be wise enough not to confuse them. The value for the listener is simple but lasting. A truthful mystery is better than a loud certainty. It allows the mind to rest, not because everything is solved, but because nothing has been forced. The forest fell quickly, but understanding moves with a slower grace. It moves through evidence, through humility, through the quiet refusal to make the unknown larger or smaller than it is. In the last view of Tunguska, nothing needs to be made louder. The quiet facts are enough. A forest stood in central Siberia. A sudden force arrived from the sky. Trees fell across a vast reach of taiga. People saw light, felt heat, heard sound, and remembered fear. Scientists came later and found a damaged landscape that pointed strongly toward a natural airburst, while still withholding some of the fine details that would make the event feel fully closed. This is the honest shape of the story. It is not empty mystery, and it is not total certainty. It is a real event known through traces, patterns, memories, absences, and careful comparison. That may be why it continues to matter. It teaches that truth does not always arrive as a single object lying in the center of the scene. Sometimes truth arrives as a ring of fallen trees, a missing crater, a witness memory, and a question that becomes smaller but deeper as evidence is followed. The forest was flattened quickly, but understanding had to move slowly. It had to cross rivers, years, political upheaval, scientific uncertainty, and the natural decay of wood. It had to accept that the most violent moment happened in air, in a place no one could later walk through or collect whole. What remained below was not the event itself, but the event's shadow. Human beings have always lived by reading such shadows. Our earliest ancestors read footprints, broken branches, ash, animal calls, weather, hunger, and changes in the land. They did not own the world by understanding it. They survived by paying attention to what the world left behind. Modern science is a greater and more disciplined form of that old attention. It looks longer, compares more carefully, tests more patiently, and admits limits more clearly. Tunguska belongs to that long human movement from fear toward careful knowledge. The event began as sensation. Brightness, pressure, heat, trembling, and sound. It became memory. It became a damaged forest. It became investigation. It became a scientific explanation with open edges. And finally, for us, it becomes a lesson in how to think. Not every unknown is an invitation to believe anything. Not every strong answer must pretend to be complete. Between those two mistakes lies the quieter path. The path says, here is what the evidence supports. Here is what remains uncertain. Here is where imagination must bow to the marks on the ground. That lesson has value far beyond one Siberian morning. It matters whenever we speak about ancient people, lost worlds, extinct relatives, sudden climate shifts, unexplained ruins, or the deep origin of human life. The past is often broken when it reaches us. It comes in bones, tools, scars, sediments, tree rings, and stories that have outlived their first speakers. If we force those remains to say too much, we lose truth. If we dismiss them because they are incomplete, we lose truth in another way. Tunguska asks for the middle way, patient, humble, and awake. It also reminds us that the sky above human history has never been only decoration. It has shaped climate, seasons, light, navigation, imagination, fear, calendars, stories, and survival. Most nights the sky is quiet enough to sleep beneath. Most mornings the forest remains standing. But the Tunguska event shows that rare forces can cross that quiet without warning, and that life on Earth is part of a larger physical world than daily habit allows us to feel. This should not leave the listener with fear. Fear is too small a final answer. A better ending is respect. Respect for the people who felt the blast and could only describe what their bodies endured. Respect for the forest that held the pattern long enough for later minds to read it. Respect for science when it narrows uncertainty without pretending to erase it. And respect for the unknown when it is real, bounded, and not yet fully recoverable. The educational value of Tunguska is not that it gives us a shocking secret. It gives us something calmer and more useful, a way to separate evidence from invention, and wonder from exaggeration. A truthful mystery can make the mind quieter because it does not demand false drama. It allows the world to remain large without becoming careless. The trees that fell in Siberia are no longer the living forest they once were, but their pattern still speaks through the history of investigation. It says that energy can arrive invisibly, that absence can be a clue, that memory can matter, and that knowledge is strongest when it knows its own borders. So we return to the first question with a slower mind than before. Something flattened tens of millions of trees in seconds. The best evidence points toward a natural body releasing its energy in the atmosphere above the taiga. Yet the exact visitor, its final breakup, and the full shape of that vanished moment remain partly beyond our reach. And perhaps that is where the story should rest, not as a closed answer, but as a quiet question beneath the sky. When the Earth keeps only the shadow of an event, how much of the truth can human beings ever hold?